वन्दे मातरम् वन्दे मातरम् Thank you all. I would now invite Dr. IOTAPC Brother Sir, coordinator of the Gian program, to address the session. Thank you.
A very good morning to all. It gives me a pleasure to introduce the course today. The Department of Electrical Engineering has got the privilege of conducting a course on IoT and predictive control. Usually, we see that the majority of the courses that are conducted by the electrical department are related to electrical engineering, but this course comes with a breeze of fresh air. Today's date requires that it's not only a possibility to work in a single field, but we need to collaborate with other fields, learn from other fields and integrate it into our systems. So probably IoT is one of those courses where we try to integrate it with electrical and see the benefits of it. I am proud to say that this course should be able to achieve the same. I am also delighted to share that we have participants coming from different parts of the country, extending from Kashmir to the south. The participants also include members from IITs and NITs and various renowned institutions. We have research scholars as well as faculty members as participants, and one very good combination that we have each other. This course would provide a great platform to share our knowledge and make new connections. The course proposes to cover topics like theoretical as well as the hands-on session. I thank our director, Professor Vidya sir, and Dean IITA.
Department of Electrical Engineering offers B.Tech in Electrical and Electronics Engineering, M.Tech in Power Electronics and Drives, Power Systems Engineering, Smart Electric Grid, and M.Tech in Control and Automation. Just started last semester. And PhD in all the major fields of electrical engineering specialization. We also have self-finance programs in M.Tech, PG Diploma and PhD. And they were started in 2021-22. At present, 136 students are admitted through JEE in B.Tech. Around 95 students through GATE in M.Tech programs. At present, around 100 research scholars are working towards their PhD degree in the department. And many funded research projects sanctioned by various agencies like MOE, MHRD, Imprint, Spark, DST, SERP, CPRA, been executed to a tune of 650 lakhs. Very recently, DST FIST project cost more than 1 crore, is also sanctioned to the department. At present, around 9 to 10 junior research fellows are working towards these execution of these projects. Department has state-of-art equipment such as programmable DC power supplies, programmed solar simulators, high-end mixed signal oscilloscopes, digital storage oscilloscope, multi-level inverters, lab view software, hardware development kits, digital signal processor kits, etc. We also have grants released by MHRD TechCube and various funding agencies towards procurement of a lot of equipment in our emerging laboratories. The department has a strong industry interaction and has been involved in constantly handling various consultancy projects for various industries and lift irrigation projects of government of Telangana and Andhra Pradesh. Department has an MOU with Central Power Research Institute, Bangalore, ABB Power Product System India Limited, Bangalore, Power Grid Corporation of India Limited, Power System Operation Corporation, POSOCO, and also it has got a very good interaction with Hitachi Energy India Limited. Student support activities. We also have Electrical Engineering Society supporting the student activities, and we also have IEEE student branch and women engineering, student mentorship programs, industry visits, industry lecture series through Electrical Engineering Society, and in curriculum related courses are taken up in our department. Outreach activities, prestigious faculty development training programs are sanctioned to the department sponsored by the Government of India under various prestigious schemes like GAN, ATAL, Spark, E&ICT, MIT, TLC, NIT, etc. Faculty also constantly conduct STTP through which our department faculty are contributing to improve technical education in various domains of electrical engineering community in the region and across the country as well. Apart from this, department faculty are actively contributing towards various academic and research activities to the community of technical education. MTech SCG program was going on very well, started during 2020-21. Hitachi Energy India Limited, our alumni working there contributed a full-fledged lab in this regard. They also contributed electric cards to our institute. The department having good placement record, around 90% crossed this year till date, and we also have alumni occupying positions in Indian Administrative Services, IES, and they are also working as CEOs of multinational companies. With this brief about the department, I welcome you all to this GAN course on Internet of Things and Predictive Control. Thank you, one and all.
Thank you, sir. Now I kindly invite Professor S. Srinivasa Rao, sir, Dean IRAA and Local Coordinator of GAN Program, NIT Warangal, to address the gathering.
Good morning to all. First of all, I will welcome the foreign Professor Mohammad El-Sisi, Professor in Department of Electrical Engineering, National Kyoisong University of Science and Technology, Taiwan. Heartily welcome to India, sir, and heartily welcome to NIT Warangal campus. Hope you will enjoy the campus life as well as interaction with the participants and faculty members. You will have a nice, comfortable stay at our campus. So respected Director Professor Vidyadhar Subodhi and Foreign Professor LSSC and Head of the Department Professor NVC Srikanth and Course Coordinators for this Internet of Things and Predictive Control, Professor Altaf Badar and Professor Devasmita Panda, and dear participants, research scholars, faculty of Department of Electrical Engineering, and good morning to all. So it is my privilege, or I have an advantage that our Professor Vidyadhar Subodhi, Director, is also belongs to our electrical department, and he is a lot of expertise in control engineering. All of you may be knowing very well because we all are in electrical. So we have a We are very happy, sir. You are belongs to our department, and you are inaugurating this electrical department course. So in this GAN course, GAN phase 4, we got so many courses for electrical department. This is the third course which we are running now. Few more courses are yet to be completed by June, July. So myself, I am a professor in Department Professor Srinivasa Rao in Department of Electrical Engineering, and I joined in 1996 February, and I was given as an additional assignment of Dean International Relations and Alumni Affairs with a lot of trust and confidence on me. So I thank Director for assigning this additional duty. So we are working hard under his dynamic leadership to increase the international collaborations as well as alumni connect for development of institute, and we want to make the institute as a worldwide recognition under his dynamic leadership. We are very much thankful for him for continuous encouragement towards getting international collaborations for NIT Warangal and student exchange programs and internship programs and faculty exchange programs. He is very much encouraging us, and we are also working from our Dean office side. So as a customary, I will introduce about the GAN and its objectives. It was initiated in 2015 by Ministry of Human Resources and Development. Then now it is called Ministry of Education, Government of India, to tap the talent pool of scientists and entrepreneurs internationally to encourage their engagement with the Institute of Higher Education in India, Institutes of Higher Education in India, so as to augment the country's existing academic resources, accelerate the pace of quality reforms, and elevate India's scientific and technological capacity to global excellence. The main objectives of this GAN are to increase the footfalls of reputed international faculty in the Indian academic institutes, provide opportunity to Indian faculty to learn and share knowledge and teaching skills in cutting-edge technologies, to provide opportunity for Indian students to seek knowledge and experience from reputed international faculty, to increase avenue of possible collaborative research with international faculty, to increase participation and presence of international students in the academic institutes in India, opportunity for the students of different institutes to interact and learn subjects in the most advanced areas through collaborative learning process, provide opportunity for the technical persons from Indian industry to improve understandings and update their knowledge in relevant areas, motivate the best international experts in the world to work on problems related to India, develop high quality course material in advanced areas in the form of video recording and live webcast so that it can be used by large body of student and faculty community throughout the world, to document and develop new pedagogical methods in emerging topics of national and international interest. So NIT Warangal has got phase 1. Phase 1 started in 2015-16. We got 27 courses at that time with a sanctioned amount of 1.8 crores. In 2017-18, GAN phase 2, we got 41 courses with 2.48 crores. In 2019-23, around 21 courses were sanctioned with 1.41 crores budget. Now GAN phase 4 is running. We got till now around 23 courses were sanctioned. Out of that, many courses were sanctioned to electrical department. As on today, we got budget of around 1.45 crores. So our special thanks to Dr. Anil Agarwal, National Coordinator and National Coordinator of this GAN Hyderabad. It is located at Hyderabad, now monitoring all the activities of the GAN phase 4 programs from IIT Hyderabad. This GAN phase 4 is slightly different from GAN phase 1, phase 2 and phase 3. In this phase 4, it is mandatory to webcast the all lectures, and video recording is also compulsory, and every day the attendance of the students also has to be updated to the national coordinator located at Hyderabad. This program is closely monitored, and they are also instructing us to circulate this web link to all the students and faculty throughout the country so that they will get a lot of exposure from the foreign eminent professors. So in total, 48 foreign faculty were collaborated with NIT Warangal under various programs, GAN as well as Spark programs. The foreign faculty who came from different countries are UK, USA, Australia, Belgium, Israel, Canada, Singapore, Germany, Italy, Japan, Malaysia, Europe, Norway, Portugal, Romania, Russia, Slovakia, Sweden, Taiwan, Greece, Denmark, France, England, Scotland, Finland, and Middle East. In the recent past, many foreign faculty visited this campus the past 50 days under various schemes such as GAN and Spark programs. Professor Rahul Rai from Department of Atomic Engineering, Automotive Engineering, Clemson University, USA. Professor Alfred Joseph from University of Tennessee, USA. Professor Tania Datta from University of Tennessee, USA. Professor Gian Shawarj, University of Tennessee, USA. Professor Vijay Raghavan, McGill University, Canada. Professor Maxim Shatov, University of Cytology of Russian Academy of Sciences. Professor Shrikant Joshi, University of West Sweden. Professor Channapat Paniswas, Queen Mary University, London. Professor Indrajit Chaubey, University of Connecticut, USA. Professor Rahul Ratnaraj, University of Edinburgh. Professor Gian, School of Electrical and Electronics Engineering, National Technological University, Singapore. Professor Rahul Jain, National University of Singapore. Professor Ranjit K. Soman, Delphi University, Netherlands. Professor Leon, University of Twente, Netherlands. Professor Israel Cohen, Technion University, Israel. Professor Rukmi Datta, School of Electrical and Telecommunication Engineering, University of New South Wales, Sydney. Professor Yao Ming Chen, National Taiwan University. Professor Jim Ching Chen, Department of Electrical Engineering, National Taiwan University. Professor Sudesh Gade, University of Ottawa, Canada. All these people have visited the NIT campus for delivering lectures under Spark and GAN programs and enlightened our research scholars, faculty members, and participants who came from various parts of the country. So under the dynamic leadership of our director, not only the Government of India sponsored programs, we are also exploring possibilities for getting international collaboration with many institutions so that we will get a lot of reputation at international level at the soon. So our special thanks to our director, Professor Vidyadhar Subodhi, sir, for encouraging us to involve with international activities. Thank you one and all the participants who came from different parts of the country to listen to the foreign professor on Internet of Things and predictive control. We know that Internet of Things contains so many engineering subjects, that is electronics, computer science, as well as a control system courses are involved. Out of that, predictive control is nowadays, it is very popular. It is having its own merits, so that is predictive control is implementing in IoT, so that IoT will have a lot of boost, and we will by sitting at one place we can able to monitor the whether it is a substation or generating station or anything which are far away from our place also can be monitored through IoT. So you will be getting lot of knowledge from the foreign professor. So once again I thank him for coming all over the Taiwan to NIT Warangal for enlightening us. Thank you one and all.
Thank you, sir. I request Dr. Debasmita Panda ma'am, coordinator of the Gian program, to introduce the foreign expert, Professor LCC sir.
So, respected dignitaries on the dais, our international faculty for the course, Professor Mohammad LCC from Taiwan, Professor Vidyadhar Subudhi, Director NIT Warangal, Professor S. Srinivas Rao Sir, Dean IRAA, NITW, Professor N.V. Srikant, Head of the Department, Electrical Engineering, and the coordinator, Dr. Altaf Badar. Of the stage faculty members, the participant, a very good morning to all. I take the pleasure to introduce you to Professor Mohammad LCC from Taiwan as the guest of honor for this international GAN course on Internet of Things and predictive control. So Professor Mohammad LCC received MS and PhD in electrical engineering from Behna University, Egypt in the year 2014 and 17 respectively. He is currently an associate professor in the Department of Electrical Engineering, National Kosung University of Science and Technology, Taiwan. Earlier to that, he has served as an assistant professor in the Department of Electrical Engineering, Behna University, Egypt, and also worked in Industry 4.0 Implementation Center, National Taiwan University of Science and Technology, Taipei, Taiwan. He works in the area of IoT applications towards energy management, smart buildings, IoT-based detection and in the cyber attack, data uncertainties, and model predictive control application related to electrical engineering. He has more than 100 research articles published in reputed peer-reviewed journals. He has more than 400 citations with a H-index of 38. Many ongoing research project has been completed by him, and also like ongoing and completed research grants under him. He is also a senior member of IEEE. On behalf of the entire NITW fraternity, I would like to welcome Professor Mohammad LCC to share a few words. Thank you, Professor, for taking your valuable time for making this program successful. Sir, please.
Good morning, everyone. Nice to meet you today, and thanks for all director and Professor Sarilo and all attendance today. It is my chance, and I am very happy to open new collaboration with India. India, it is a strong country in electrical engineering for me and other, I mean, topics also, and I hope we can do good collaborations together. And currently, all of topics and all of engineering department are close together, and we need to integrate our research topics, and we need much collaborations to improve our environment related to emissions, and we need to improve our effort related to increasing of using renewable energy and increasing of applications related to IoT. All of this can help us to integrate many macrogrids together and encourage users and encourage developers to use renewable energy. We need to have new technology. New technology, it is more important for us because the main challenge for renewable energy, it is the implementation cost and automation and coordination between this. So our effort and improvement of technology and develop new methods, it is important for all people in all world. So we need to think what is our effort, what is our outcome to help people. It is important. So our target to help people like this, so we can do. If we don't have target, we can't do anything. So we must have target first. What is our target? I am electrical engineering. What is my outcome for these topics? It is important to have your target first. So now our target pollution do many problems for all of people. So if we can decrease the using of thermal power plant and using renewable energy, we can help people much. Okay, so if we consider to focus in our basics related to electrical engineering and mathematical operations, everything like this, it is not enough. We must improve ourselves and go with the world. World now, information technology, it is more important for us. So we need to integrate this technology with us as electrical power system, and how we can use this. What is the benefit of new technology for us? So everything, it is like black box for you. if you didn't research. So we must research. We must understand. When we have something we don't understand, so it is good point and good initial. So we need to go and research. So we need to open for us the research topics. If we stop, no research, no discussion, no any problems. So we need to collaborate. When we collaborate together, you have new idea, I have some idea, so we integrate together. This it is important. Don't depend on yourself. If you depend only on yourself, you only close yourself in a small area. But if I have more connection, more collaborations, we can integrate together, we can improve ourselves. So I hope this course, it is only one initiative for you. Maybe we will introduce Internet of Things and the predictive control. And if you interest, we can go in more branches after do this. Predictive control, it is good controller for me because you can formulate the controller as you like. It is not specified in certain control law. That's why we select predictive controller. Predictive controller, according to the problem, you formulate your control law. So it is important topics now. Can apply in any application, not only power system. Okay? For Internet of Things now, maybe we need the machines to talk together. It is new generation now, okay? Machines can take action together. It is important for us because maybe if we depend on ourselves, we have much mistakes. But if you design your system and the machines can take action together, so it is important for us. We don't depend on human much because human now maybe a lot of mistakes, maybe some work it is very hard. So the machine can do and the machine can talk together. After machine can talk together, what is the control? What is the control action? Okay, so we can use model predictive to take the control action. Okay, so we try to integrate something. We can apply these topics in autonomous vehicles. We can apply these topics in renewable energy. So it is only general. We say Internet of Things and the predictive control. So it is because maybe some of you work in electric machine, some of you work in power system, some of you work in control. So you can apply for any engineering topics. That's why we select in general like this. And I hope you can do some experiment. Experiment, it is more important for us. If you only study, do simulation, no experiment, no good outcome, okay? Because, for example, when we do simulation, we have some problems. We try to solve. When we do experiment, another problem come, okay? So we try to solve. So you have complete solution. So most of journals, most of company ask us, what is the outcome? If you say, I did some study in predictive control, I did some study Internet of Things, we'll ask you, what is your project? So project, it is important, okay? When you try to learn something, you need to have plan. You need to have project first. Okay, project can push you to do something good. Okay, maybe do project with some company, do project with your, institute. So you must have plan and do some, outcome for this plan. Okay, so plan, it is important for us for this course. I hope you can get some outcome from this course. and I hope we can integrate other, project later. So this is only initial, and thank you for your listening. Thank you for director and all, members here. Thank you.
Thank you, sir. I now humbly request Professor Bidyadhar Subudhi sir, Director of NIT Warangal, to share his thoughts.
A very good morning to all. First of all, I am glad that two events are running concurrently in the seminar hall, so that signifies the amount of contribution, the amount of enthusiasm in the NIT Warangal fraternity. And then the second aspect of it, that the Department of Electrical Engineering is very proactive in conducting so many GAN courses. And I take this opportunity to join with the department and the institute to invite our international expert, Professor Muhammad LCC, to this GAN program, and who is very much accomplished in these chosen areas of this GAN program. I believe his insights, his deliberations will definitely benefit our not only our participants but also our faculty colleagues and PhD students as well. And I would also request particularly the professors of the department to take a additional measure. Next time when we conduct, the hall should be full, completely full with all PhD students, because I believe the electrical department would have 100 PhD students. And now, therefore, I am now trying to develop the seminar technical writing evaluation policy is to include your passion of listening and articulating the different aspect of other experts rather than your own areas of expertise. So then what will happen, you will try to correlate that what is happening this area and how best I can take that technology or trick to your area for obvious benefits. And to me, what I understand here is that what Professor Srinivas Rao and the head and both the coordinators, Professor Altaf and Professor Devasmita, they have all taken a serious measure to organize this kind of program here. So what I personally understand is that this basic objective of this global initiative of academic network at the GAN is to expand our horizon of learning by inviting experts from different parts of the globe to our campus and listening them. So I consider it a wonderful opportunity. Therefore, my request to the head, next time when you conduct such programs, it should be mandatory for all PhD students. So we'll take a call on the seminar on technical writing evaluation. If at least 5 such programs are not being attended by a PhD student, it will be taken negatively. Okay? And then not only the professors who are conducting this program, also the entire faculty should be there in the hall, just to cheer up the coordinators. And then I must thank my earlier, the former colleagues here, kind of enthusiasm in them to come over here to encourage our faculty colleagues to do it a very, very fruitful manner. So coming back, the topic chosen is very interesting because I believe in this way. We all are fascinated by the term internet. So we send messages, we do a lot of things through internet. Now the time has come, not only the man is controlled by the internet, the machine should be controlled by the internet. Everywhere, every place, every latitude, longitude, every machine, every equipment should be connected by the internet. I am here, I can still control whether my fan is running in my room. Okay, so Internet of Things is definitely making a paradigm shift in our way of lives, every part of our lives. And obviously it is a rightly chosen topic. That's more contribution needed from the electrical engineering fraternity. And I believe a lot of opportunities there, because what was uncommon yesterday, today it is becoming more common and more practical. So therefore we have to dream what next. If it is Internet of Thing can control man-machine engine, why not it control the governance? Why not it control our, day-to-day life in all aspects? Like if I travel, that if I'm sick, I don't know my parameters. So you have all the watches that say that your heart rate, your blood pressure, your sugar limit. So immediately I should be, suppose I am in a remote place. So how can I be connected to a hospital? Okay. My drain is not rightly cleaned. How can my drain will give a message, okay, I'm clogged, clean me up. I'm traveling in my car would say, no, the car is not right, your pressure is going down. Add on the pressure at the state value. And I'm flying on a helicopter. So why my helicopter will not say me, don't ride me now, I am not in a good condition. So most accidents can be prohibited. So that kind of thing is needed. And so of the electrical engineering topic, what you have coined it has a lot of relevance. And model predictive control, if I consider, so way back if you see the literature, the more interest in chemical engineering. And basically the processes were being controlled by model predictive control. And then people realized that it is a control where the optimal control is involved here. You have to, every iteration, you have to optimize the objective function. So therefore you have to have a horizon where your control is tailored, action is tailored to give the best optimal control action to meet the objective of the control. So therefore model predictive control will now be a buzzword for every aspect of electrical engineering, because fascinated by the chemical engineering applications, the model predictive control last 10 years or so, maybe 20 years, it has taken a new paradigm shift in electrical engineering, particularly the drive applications and the microgrid applications. And of course, the electric vehicle application I am quite fascinated to see. The basic idea is that what I want to do, I want to predict in terms of, I am to optimally find a control action so that optimally I can achieve the goal. So setting a control horizon, setting a objective function, and online how to optimally do it, because online optimization is inbuilt in here. So therefore optimization, that is the real-time optimization and the platform where you optimize, is more important than ever before. And it is quite possible because of the computing technique also evolving at a very faster rate. So those of you who are the young PhD students, I believe you have a lot of potential in making a good progress in new kind of algorithms. What kind of model you need for the model predictive control, what kind of feedback you need, whether it's a feed-forward control, whether you have to set a objective function, and how best you can apply to different processes. Like one of the system you are considering the electric vehicles. So I believe each of the lectures being delivered by the expert will be very much fruitful to you. And I believe you carry away or you take away the benefits of this model predictive control of your research and try to get the best benefit in publishing them in the high quality journals. And if you just scan the IEEE transactions today, particularly the industrial electronics, you will find a lot of application of model predictive control in the drive system and microgrid control. So the open area electric vehicles, I believe the still is a very nascent stage, and you have enough opportunity to do so. I once again congratulate the coordinators, both Professor Altaf and Professor Devasmita, for choosing the right topic and coining with the international expert to chalk out it for a 1-week program and setting the program schedule in the right direction. And I believe the course will be very, very meaningful. And I, at the same time, thank our Dean Alumni for taking a very, very, pragmatic step how to increase the number of GAN program. I believe amongst the NIT system, NIT Warangal is the forerunner in terms of organizing the GAN programs. So all kudos to our international division. And the department in particular, the electrical is very, very productive, and I believe a lot of outcomes are expected, not only in delivering lectures, but the foreign collaboration in terms of joint program, mobility of the student to there and here, mobility of the faculty there to here. Lot many can be thought up and mutually discussed during a stay here. And I urge all the students over here to propagate the message that this endeavor should not be limited only listening in the class. That should be extended in multi-front to take it a new dimension of really fulfilling the mandate of the country in reaching out the global networks across the globe. Thank you very much.
Thank you, sir. You have always been a guiding light for us. Now I request Professor Vidyadhar Subudhi sir, Director of NIT Warangal, to felicitate our foreign expert, Professor LCC sir. Clap, please. Thank you, sir. Thank you, sir. Now I would like to invite Dr. Altaf Badar sir, coordinator of the Gian program, for addressing a vote of thanks.
Thank you. When I come on stage as an anchor, I have a different role, but now as a course coordinator, my tongue is tied actually. To begin with, I would thank the Almighty God who has given us the capacity and the resources to conduct such programs. To be very frank, if I don't say this, then I would regret it. Actually, what happened is the course started we planned it around in August. And the publicity started and we worked very hard. Around December, we had the target number of participants, so we stopped the publicity after that. We did all the other background work by that time, and I was feeling that everything is going very smoothly. And then suddenly a bomb came up. The NEP was to be organized by the institute, and the dates collided, and suddenly there were some issues which came in. And it is very important to mention that the director himself took the responsibility of providing all the facilities which were now restrained, so that the program still goes on. So my gratitude to the director, Professor Vidyadhar Subudhi sir, in absentia. He really played hard. In fact, before me, he used to go and inspect many of the things, whether they have been completed or not. We are obliged to the foreign faculty, Professor Mahmood LCC, who has taken time out, and he did not even not only helped us design the course, but he also helped us in acquiring the equipments and other things, and he has taken time out, traveled all the way through. Thank you, sir. The continuous support and guidance extended by Dean IRA, Professor S. Srinivas Rao, has been the backbone to conduct this event. Thank you, sir. We are thankful to the IRAA office also. They have always been prompt in addressing our issues. We also thank Professor N. V. Srikant sir, Head EED, for his constant support and guidance. The vote of thanks cannot be completed without acknowledgement to the strict office headed by Professor Shirish Sonavne sir, Dean RNC and ITW. The staff of SRIC has been really cooperative with us. Our heartfelt thanks to all the faculties of the department and office staff. We are also thankful to Professor Anjanelu sir, Professor S. Shankar, Professor Azim, Professor Biswas, who have helped us and has been great support to us. A great thanks to Professor Saidulu sir in absentia again, without whose help we could not have arranged the hands-on session. I also thank Professor Subramaniam sir and Professor Saidulu sir for attending the inaugural function. In absentia again, thanks to Professor Sailaja madam, because she also helped us for acquiring of the equipments. I thank our PhD scholars Om, Shahbaz, Pavni and Shweta. Without them the course would not have been possible. They have really worked day and night to get the things done. Thanks to the participants who are the soul and have come from different places in India. I assume there are obviously problems in traveling and all of it, but your cooperation is much needed. And I thank all the other persons involved directly or indirectly in making this event successful. Thank you.
Thank you, sir. We would now rise for the national anthem.
भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल वंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Thank you all. There is a refreshment arrangement outside. Okay. Thank you. Please join everybody for a group photograph.
and transactive energy market. She has won Best Paper Award at IEEE Conference Bangalore, India in year 2017. She has authored 4 book chapters and peer-reviewed many journals. She also serves as a reviewer to many international journals like Electrical Power System Research Journal, elsewhere, Journal of Emerging Electric in Power System, and also being technical committee and members of many international conference. She is a member of IEEE, member of Power and Energy Society, member of Solar Energy Society of India. Over to you, ma'am, and welcome to the session.
I think my voice is audible without the mic, so but still, yeah. So, very good morning to all. So today we will, so I will be initially introducing you related to very basic introduction to what is a model predictive control and like the concept behind it. Then how we will like apply it to our electrical engineering domain, because as you might have heard from the morning that it has initially started with the chemical industry, and this is something we started from the industry came to academia. Like it started with the cell industry, then the academia people used it for their research. So I'll be giving you a brief overview related to model predictive control. So, okay, and how it is different than a normal control? Normal control in the sense we are, what does a control means? Because I want the session to be a little interactive. What do you mean by a control? Yeah, I want answers from the participants. Whatever you know, it's nothing that we are going to judge or evaluate anybody. So, what do you mean by control? Exactly. So, we are trying to get something to a desired value to obtain a desired output, right? But then that can be done by any controller, right? We have PID controller, we have well-developed controller. So how does MPC is different, right? So that we are going to discuss. Yes. Yes. Yes, yes. I think people are having some basic background about MPC. So we will be quickly covering introduction to MPC, the motivation for the MPC. We will try to understand through basic examples. Maybe few of them know MPC, but many doesn't know what is a MPC and how to use it. So I will start from a very scratch level to understand with a very practical examples or our day-to-day life example to understand the MPC concepts. The terminology that we use in model predictive control, classification of the MPC, the state space model of it, and we will also have a MATLAB hands-on session on MPC design for photovoltaic cell. But for that I need MATLAB. So for initial 1 hour I'll be covering the basics today. Maybe in tomorrow or sometime within this 5 week we will have a MATLAB hands-on session on the MPC design for a photovoltaic cell. So I'll give you the problem statement and we will design it together. So for that I insist all of you to install MATLAB having MPC toolbox in it. Like the toolbox should be added as MPC with controller as also as a toolbox. So as per definition, model predictive control is one of the popular control in the advanced control approaches, and as somebody has already mentioned that it is going to predict from the model what is going to be the future control horizon in order to achieve the optimal output that we require, right, for a given set of input. That means it predict the future. So do you think it is a fortune teller? It will predict the future. How it will predict the future? Right? So that is what we will see. So how it will predict the future. So any MPC will have, because we are trying to achieve certain objective. Okay, so I will come to this slides later. Maybe the positioning of the slides is a little disturbed. So this is the traditional view of a controller. So if you see here, this is the plant. What is a plant? So plant is a term we use in MPC very much. So what is a plant? Plant is nothing but the on which we are trying to apply the control strategy, right? So in chemical industry, it's like a chemical plant using some chemical, giving some output. So that's why the name plant has come derived from there. So there is a plant, and the plant is having input and output, and the input, there is also some real-time disturbances that we don't have control over, right? And what the traditional controller does is that it takes the output as a feedback, and based on a set point, it calculates the error and try to minimize the error through the controller so that we'll get the desired output. Okay, so that is how is the traditional controller work. But is it that only output that we want, or is the output is straightforward? No, sometimes the output are also depending on some real-time scenario that the traditional controller cannot capture. So that's why the term, the MPC controller is very much beneficial. I may be in between using the, what you can say, the notepad. So here, inside the MPC controller, what is the different? Like earlier case also, I was having a controller. So now also, I just replace the controller with the MPC. But the difference is that, in this MPC controller, I will use the plant model and try to optimize the objective that we want to achieve. And in order to achieve the objective, what could be the input to the plant so that we'll get the desired output. So inside the controller, I'll have the plant model, and the plant model we are going to use the optimization objective, optimize it, get the state of input to the plant so that we'll achieve the desired output. So output we'll take it as an input to the controller. We'll try to optimize that output towards achieving our objective and give that as an input to the plant so that we'll get the desired output, right? So, but it is very easy to say like that. We will step by step understand. So there are different stages to model a MPC. We will understand it. So you can see, so what is the plant model? What do you mean by a plant model then? How do we represent? Because something we are optimizing means it has to be in form of some mathematical equations. So we will use the state space model or discrete state space model of the plant, and towards achieving the objective, we will write the objective function to minimize the difference between the expected output and our current state. So if you see here, this is the plant model, which is nothing but a state space model of a plant. And MPC has an added advantage that it can handle the constraints, because the variable that the input variable that we are giving it to the plant can have constraint. We will see through example. And towards achieving the objective could be minimization of the cost, maximization of the profit, or it can be anything. So towards achieving this objective, we will model 3 of this together to get the desired input. Okay, so let us take a very simple example. Let us say today's, or in, you can consider any one day, or for today, let us see. You want to understand the concept of MPC, model a MPC model, and see whether it is working or not. I have to like check the functionality of the MPC. So that is our objective or the goal to achieve in today's session. So in MPC, so we are beginning at 12 o'clock. So our aim is to understand, design the MPC case study. Stage who doesn't have any idea of it, right? So we have to work as a team. And the rule is that whenever we try to achieve the goal, we plan it, right? So what is our planning? So the planning, the end goal is that we have to reach there to modeling of the MPC. To reach there, we will achieve, we cannot directly jump there, right? We have to stage by stage understand. So we will plan for next 8 hours, from here 8 hours or 6 hours or 5 hours till 5 o'clock or 6 o'clock in the evening. We will plan for the next 8 hours, but execute the plan in each 1 hour, isn't it? So after 1 hour, we will see how much is our progress. Then after 1 hour, depending on the current state where we are in, like what is our understanding level, how much we have covered related to the concept, designing of it, again we will at 1 o'clock, we will again plan for next 8 hours. So window of 8 hours is fixed, and every hour we are going to modify that strategy that we are going to take to achieve the objective. Are you understanding? So I'll be using the notepad in between. Yeah. So we said that the day is beginning at 10 o'clock. Oh, sorry. So day begins, but now it is, I thought that it will 10 o'clock, now it is being 12 o'clock, which is not in our control. So that is what the MPC is going to do, that which is not in our control, we are trying to optimize it. So we are beginning at 12 noon, and what is our objective? Objective is to understand, then model or design the controller, and we will validate it with some case study, right? Now what is the rule of the game? As I said, what should be the strategy that we are going to make? One is that we have to work as a team, and at every 1 hour we have to plan for the next 8 hours, 6 hours, 7 hours, depending on how long we'll take. But in whenever we plan, we fix it for the whole day, right? So let us say it is 8 hours. So we always plan for next 8 hours of work. But we implement, but the implementation is for how long? Implementation is for 1 hour, because after 1 hour again we are going to re-evaluate at which state we are in, and then we are going to plan for the next 8 hours. Okay? And repeat this process at every hour till we achieve the objective. Fine? Now, in between what happens? So first when we do, we divide the task. Let us first model it, then design it, then simulate it, then implement it. We are dividing. So let us first understand, then model it. While doing this, completing this task, there may be some undesired situation happen. What are the undesired situation that can happen? That is what? What could be the disturbance? That event will not disturb our hall. The disturbance that may be because now we are a team, right? We are working as a team, we have a certain time constraint, but the disturbance that can happen is that somebody in between got some urgent call to leave the team, right? So we have assigned some task to that person. Now that person leave the team. Then is it not going to affect your process of reaching that 8 hours window or that achieving towards the goal? Yes, right? So in between I can have different variables that may affect the process of achieving towards the goal, which is not in our control, which we'll call in MPC term as manipulated variables. Manipulated variables. Right? So what are these? These manipulated variable are nothing but if somebody leaves in between, or like if somebody is not working, he is inside the team but he is not working towards achieving the goal, like he is not helping you in modeling or understanding the problem. So that's something that is beyond our control. So those are called manipulated variables in MPC. Okay? Now, what is the limitation that we are having? So this is something we will be frequently using in MPC, manipulated variables. What are the limitations? Limitation is our ability to understand or our technical knowledge to understand or basics that we are having to understand the concept. If I cannot make somebody from HSS department sit here and trying to teach him MPC. Isn't it? Is it possible? No. And some people have already background knowledge of MPC, they can catch the concept faster, they can implement it faster. Somebody who doesn't have, even if he is from a technical background, he doesn't have proper exposure towards the MPC, so he may take a little longer time. So the limitation of individual member in the team is something that is going to affect your reaching towards the goal, right? So that is called constraints in MPC. So that means a variable I can vary from some minimum to maximum, like everybody is having a minimum knowledge up to a maximum knowledge related to the concept. So if you have, and how early you catch the concept of MPC and implement it is something, it is in the control of yours, it is not in the control of the overall team, right? So that is called the constraint of a problem. Okay, so the limitation are, and not only your understanding concept, knowing the software, knowing the hardware component that is involved in the modeling is something that may not be there with everyone, right? So that means you are constrained towards implementing the goal in that particular given time horizon which is being given to you, right? So these are the constraints. So limitation is that ability to understand the problem and also knowledge about or skills about, we can say skills of the hardware and software. That is involved in learning this. So these are called as constraints. Now this constraint can be hard or can be soft. hard is somebody who doesn't know anything about MPC. Soft can be for someone which is already have little bit information, he can catch it faster. So some constraints are very hard, like some are very much strictly bounded and some are free, right? So that is called constraint in MPC. This is also another term that we are going to use in MPC very much. And our goal is nothing but the objective function that we are trying to solve to achieve, right? So as I said, we started with 12 o'clock. Let us say this is our time horizon. We started at 12 o'clock and we are fixing a time window of 8 hours to understand it. And the rule of the game is what? We have to recalculate after every 1 hour. So this is where we are starting, and this is where we are checking what is our progress, and we are again going to recalculate for another 8 hours. So this is the window that we are calculating right now. Then after another 1 hour, then again we are recalculating the same window after 1 hour. So this in MPC term we call it as receding horizon, or we call it as moving horizon, right? Till we achieve the desired objective. Till we achieve the desired objective. Okay? Is this clear till now, whatever? So, now the three key element that we require for the planning is what? After all this discussion, can you tell me what are the three key elements that we require for the planning? Exactly. So predicting what is the exact objective that we want to achieve, the exact goal. That means we need to model the plant properly so that we can achieve it faster without moving and second one, tell me, I am not going to spill the beans, yeah. Exactly. So based on our current state and our constraint, hard and soft constraint, how we are going to achieve the objective. So these are the three key elements. And what are the things that we need to keep in mind? That we have to work as a team and we have to maintain that 8 hour of horizon towards achieving the objective. Now, so in MPC, let us try to understand from another example. So this is one of the example. I am going to repeat this example again and again till you understand the modeling of the MPC. Another example let us take is, I'll come to the slides. This is a very famous example of MPC where we can get from anywhere. So I have also took it from the internet. So what you see here, let us say you are driving this car, you are here, okay, and there is a truck going in front of you, and you want to overtake the truck because it is a highway, only the truck is maybe obstacle for you, you want to take a turn from the truck. So initially you calculated the position of the truck, the speed of the truck, and you decided that the red trajectory is that I need to follow to cross the truck, okay. But later when you reached maybe let us say here, you will recalculate. Is it that once you have calculated at this position 1, and you will suddenly take the right turn, that red path? No, right? You are going to recalculate again at this point, again at this point, again at this point. At every instant of time that you are moving ahead, you are going to recalculate which could be the safest path to take to cross the truck, right? And after you reach here, you may be you may be seeing that there is a downhill or sloping is there. Okay, so when there is a sloping in the path, the truck speed will obviously increase, right? If the truck speed is increased, if I am going to the same trajectory, the truck might have reached this position till I take this red path. So instead of going like this, you recalculated and you have moved, or you have taken the green path, right? So this is where the MPC is coming. But now you can say this can be done by a normal PID controller. So I will check the position of the truck and I will take that as a feedback control towards the controller that is there in the car, and I'll take the green path. Is it that a PID controller can do, or is it that only one state that you are seeing for the truck, that is the speed of it or the position of it? No. So how many states you are seeing to decide that I have to take the green path? You are checking the position of the truck, which a normal PID controller also does. You are checking the speed of the truck. You are also checking your steering wheel constraint. How much minimum or how much maximum I can turn left or right. If certain unplanned situation that has happened. So can you tell me now what is the plant here, what is the manipulated variable here, what are the constraint here? Because whatever example we are trying to discuss here, we will try to connect with all the terms of the MPC that we will be using in modeling. So what is our objective here? To overtake the truck, okay? With safely, not that we will overtake the truck by bombarding it, right? We will safely overtake the truck. Next is what? Constraint. What would be the constraint? Exactly, the distance. Yes, very good. So we will be checking the position of the truck, the distance that you are from the truck position currently, and also you will recalculate it till the time you are crossing the truck. At every instant of time, you are recalculating it. That is what is called residing horizon. So at every instant of time, I am recalculating the position of the truck, the speed of the truck, and accordingly deciding that which path to be taken. So what are the different manipulated variables here? Steering, accelerator. So these are the manipulated variable. Which one is the plant here? Can you tell me? Because these are the input I am giving to the plant, and output is crossing the vehicle safely. So as I say, any controller will give a input, we will have a output, and we'll have some disturbances. And this output I am taking it as a feedback to the controller to decide what could be the desired input to the plant. So where is the plant here? The car, the vehicle, our car is our plant. So we are giving this input, we are recalculating in our mind and giving this input to the car. So plant is our car model here, right? And we are trying to achieve the desired control objective, right? So this is another example of MPC. We will take another example from the chess. So here, let us say controller is you. So this is the player 1, that is you, and this is your opponent player, right? So now your move, when you try to move your any of your whatever you can say piece over the chessboard, you will always think that because of my move, what could be the opponent move? And you not only think that, you also think if the opponent move is like this, what could be the further my move? Isn't it? So you will recalculate 5 steps further before you take your first move, isn't it? And at every instant of time, is it going to remain constant? Whatever you have thought in your mind for the first 5 moves, is it going to remain constant? No, it is going to vary depending on the opponent moves. If the opponent moves in a different way, now I will recalculate what we have calculated again, maybe in a very different manner. Isn't it? So every input that we are giving, it is based on the output that we are getting from the opposite side. Till we achieve the desired objective. What is our desired objective? To win the game. Right? So now who is the plant here? The chessboard is the plant here. What are the different manipulated variable? Pieces? The strategy to move, or you can say the opponent strategies and also your strategy. If you take a wrong turn means, or a wrong step, there you can lose the game, right? So this is how the model predictive control work. So it doesn't only take the current output state of the system, it also considered the different manipulated variable as well as what you can say disturbances that present, which is beyond its control, in order to give a control signal to the controller and to the plant to achieve the desired objective. And as I said, because now you can see I can have many manipulated variable, I cannot have a single variable, but in case of a PID controller, the variable is mostly a single variable, but we can handle multiple variable in MPC, and it is a optimization based algorithm. We are optimizing towards achieving the objective with a set of constraint. So it has the ability to handle the constraint. It allows the current time slot to optimize, and it has the ability to anticipate the future events also. So this is a simplified block diagram of the MPC. If you can see here, from the sensors, you can consider the car here. In that case, the car sensor is going to give you the output measurements, and this output measurement I will give it to the real-time server or solver along with a set of reference outputs, and inside the MPC I will with a set of constraint and all, I will get the what you can say desired control signal to the controller and then to the plant in order to achieve the desired objective. So this is how the MPC works. I can have measured disturbance, manipulated variables, some unmeasured disturbance which is not in our control, and output is measured output, unmeasured output. There can be some unmeasured output. If there is an unmeasured output, what we will do? If there is a measured output, it is okay. If there is an unmeasured output, what do you mean by an unmeasured output? That can have unknown disturbance, but that is the output, right? Okay. Okay, fine. So as you can see, it's not that we don't have significance. This unmeasured output that we are getting, maybe some way in the other is affecting your required output, but we are not measuring it. Like we are not getting the exact state of it. Then in that case, we use state estimator to estimate the state because of this unmeasured output, and again we use it as a input, a feedback input to the plant in order to get the desired output. So sometimes some outputs are not directly related to the state of the, now in case of a car movement or truck movement, we say the state of the or the state variable of this model is the position of the truck, right? But in that case, the position of there can be some unmeasured output in case of the speed. But speed we are not measuring for the truck. Let us say it is an unmeasured output. But from the speed, I can also evaluate what could be the position of the truck relative to my position. Isn't it? So how we will use this unmeasured speed of that truck to calculate the state that is useful for us to achieve the objective is what we are going to estimate using a state estimator. So in case we use a state estimator here to what you can say change the unmeasured output into to our desired input, like desired output, giving it as a feedback signal as a disturbance or any kind of not disturbance, to recalculate the measured towards achieving the measured output. As I said, the speed we are not directly measuring, but we can use the speed information to calculate the state of the vehicle position, right? So that is called a unmeasured output. Like sometimes in power system, if I see from the perspective of the power system, the states of a power system are the voltage and angle, right? But somewhere if there is no meter at a bus, I am not able to measure the voltage at a bus. I can certainly use the power flow equations to calculate the voltage at a bus, because I know that how the voltage and measurements are related, like flow measurements are related, right? So that is what this unmeasured output says. So we'll have manipulated variable, disturbance, control variable, measured variable, and states are nothing but that this is going to give us the dynamic condition of the system. Its value give us the dynamic condition of the system, and based on the states only we will try to control the output. So popularity of the MPC, as I said, at every time instant I am going to recalculate the position. So it is a discrete time control which is like very much required in real time application. At every time instant I am going to recalculate. It is a model based approach, and it predicts the future behavior, optimization based approach, easily handled control, and naturally a MIMO system. So generally we use two terms, CISO and MIMO. What is CISO? Single input, single output system, and MIMO is multiple input, multiple output system. So MPC is able to handle this MIMO. For this we can use a simple PID controller also. And residing horizon approach after the feedback update. We will, okay, so as I said, feedback control, feed forward also, we will see. So we will be, so after I complete, I'll just tell you how to formulate the objective function of a MPC and all. With that we will complete today's session, because at 1 o'clock you are having a lunch break. We will continue this, provided in the next session whenever I am going to take, I want all of you to have your laptop, and you are having laptops of your own with MATLAB installed in it. Okay, because today I'll only give you a brief overview of the MPC, but in the next class we are going to do a MATLAB hands-on session on modeling a MPC controller. Okay. Okay. So as I said, so these are the different terminologies. Sampling time is that example 8 hour, sampling time can be 8 hours also, it can be like 1 hour. In our case it is 1 hour. Time horizon is 8 hours. Prediction horizon, tell me from the example of that 1 day plan that we are discussing, prediction horizon is 8 hours, okay. Control horizon, tell me, control for the duration of the course. So you are saying that my prediction horizon can be greater than the control horizon? Is it that you are trying to say? Exactly, that is what. So prediction horizon can be longer, but control horizon is lesser than that. So it can be less than equals to also. It can be equals to 8 hours also, but this is how it is. Anyways, these are the basic concept that we have already discussed. Any manipulated variable that we are taking it as u of k in throughout this course, and we will write the objective function to minimize the sum of the error we are, the error means from the expected value to the predicted value, we are going to minimize the error, square of the error. Then we will have the equality and inequality constraint, and we will calculate the state variables. Yeah. So you can see here, what is the U here? This side, whatever you are seeing is the input, and this is the output. And whatever you are seeing to the left hand side is the past action that has already taken. Whatever you are seeing here is the future that you are going to simulate in order to achieve the target. And where is our target? This is our set point or the target. Okay. So let us say for this input, for these values of the input, when I say input, it is input to the plant. For this set of input, our output was this. Okay. Then we are now at the kth timestamp. This is our current position. Now from the current position, so because we have started from k minus 1, k minus 2 and k minus 3, at kth position we are trying to recalculate for the next predicted period what could be our best control strategy to achieve the target. And where is our target? Here is our target. Okay. So for this set of input, when the input is here, the output is this one. When I am giving input this, the output is this one. For this input, this is the output. For this input, this is the output. So at every instant of time, what we are trying to do, you can see here, from this is of my set point. So from the set point, if I calculate my current state, this will give me my error, isn't it? From the next instant of time, I am taking the information from my past behavior and again moving to the next step. This, let us say this is E1, this is E2, and if you can see, stepwise I am reducing the error till I achieve the set point. E1, E2, E3, E4, E5 up to the same figure here. Up to I achieve the, let us say there are EP predicted steps are there, so I am going to minimize the error till I reach the target set point, isn't it? So how do we mathematically model it? Exactly. So summation over, very good. So we are trying to minimize the error, and this error I can write minimization summation over, let us say this is k equals to 1 to p, because p is my prediction horizon, that is the total 8 hours. I am trying to do E1 square plus E2 square plus E3 square. And what is the E? Up to EP square. So this is up to plus EP square. I am trying to minimize, sorry, EP square, right? What is the E here? Error, but how can I mathematically? I cannot write E1, E2, E3. I am calculating this E from something from here by inferring something from here. What is the E here? My current position and the target. The difference between the current position and the target. What is my current position? Like in case of a truck trajectory, everything you can analyze analogy from the 3 examples that we have discussed for achieving the 8 hours of target of understanding MPC. So at every I am recalculating how much I have understood MPC to model it to achieve the goal.
Similarly, for the truck example, at what position I am relative to the truck position so that I can cross it safely. So at every instant of time, I am trying to minimize the error between the set point and my current position so that I can achieve the target. Right? So here, how do I model the error? Tell me, mathematically. So set point minus, why? Because if I do set point minus target, set point my current position, or if I do current position minus set point also doesn't going to change. Why? Because we are squaring the error. Now somebody can tell me why we are squaring the error? Exactly. So if there is any negative error, then I may deviate very much from the target, towards achieving the objective of minimization of error. To cancel out that, we are squaring it. Okay, and by squaring it, we are ensuring that minimum is only possible if my error is 0. Then only it is possible. So I can write this as, let us say, u of k plus I is my k plus I, where I is equals to, let us say this is I is equals to 1 to p. So u of k plus I is my current position minus the target set point, which is nothing but what we can say y set point, right? I am just writing set point as p, and we are trying to minimize the square error I is equals to 1 to p, right? So this is how we can model the objective function. Now tell me what would be the constraint, because we said that MPC can handle the constraint also. So what are the constraint here? Exactly. So steering wheel, when we are moving, how much maximum I can turn right, how much maximum turn I can turn left, right? Or in case of your whole day understanding of MPC, that means what is maximum you can capture or gather information and try to implement it in the learning process is something is a constraint within us, right? So here, can you tell me mathematically how I will represent that? In this example, as from here only we have inferences this objective function, na? That minimization of this is going to be our objective function, isn't it? So from here only, can you tell me what is going to be my constraint? So now I am writing the constraint of this same problem, because I am going to optimize the objective function such that constraints are satisfied. So one of the constraint is that my u, the control horizon that we have fixed, it should be between some minimum and maximum value that we have told about 8 hours, right? So it is from minimum 0, maximum is 8 hours. So this control horizon, so u could be from, it has a lower bound as well as a upper bound. So u or p? P. So my P is bounded by upper and lower. U is the input. This input, as I said, steering wheel position is also input to the plant. So I can say U can also be from minimum to maximum. So this I can also include that this U can be from a lower bound to a upper bound. So this small u, capital U, don't confuse. So this is nothing but, so when which is in the superscript, it is the upper, like upper limit, or you can write max also, right? What else? Can there be any other constraint? Minimum maximum speed, that is what is your u, because u is my input. Control horizon can also be one of the constraint. What else? There is another important. Position of the vehicle. Correct. Position of the vehicle is not a constraint to you. It is a input information. What is a constraint? Sampling time is not also a constraint. Okay. If my vehicle is at, let us say 10 kilometer or 20 kilometer per hour, or maybe let us say 30 kilometer per hour, can I suddenly make it to 150? Can I suddenly turn the vehicle safely from right hand to the left hand? The steps that I am taking towards achieving the objective is also a constraint. The input, delta U, the small change that you are making, that is also I cannot make it suddenly from maximum to minimum, right? I have to take it in a stepwise manner. Otherwise it is unsafe. So I cannot give some unsafe to a constraint to achieve the objective, right? Unsafe as a constraint to satisfy the objective. So I can say the del U change. So if you can see here, so if you can see here, this, let us say this is the U first position. Now I cannot suddenly go to this point now. I have to go in a stepwise manner how it is drawn here. I can go, suddenly cannot go from here to here. I can suddenly go from here to here. It is not possible. Or it is unsafe. Even if it is possible, it is unsafe. So something is unsafe, I cannot give it as a constraint to my controller. So I can say del U is limited by some lower and also upper limit. And here I am just writing it as a continuous step. Because it is discrete, you can just write k value here. K, because this k position is changing at every instant of time. So you can just put del U of k, U of k, because k position is changing. We are moving from k equals to 1 to k plus 1, k plus 2, k plus 3, like that, right? So I can just give a k function here to make it as a discretize. So this is how the constraint is being modeled for any MPC. So I am talking about the objective function that we said. So plant will use this objective function, getting information from the plant's current status. We were trying to achieve, solve the objective function with the set of constraint to calculate the state that we are going to give as an input to the controller, then to the plant. Not controller, controller will decide this. Controller is nothing but is a combination of the plant and this objective function. So this combination will give a input signal to the your what you can say plant to give you the desired output. So we are using the plant model. So if you can see here, what is the plant model here? The plant model are nothing but the U and Y values and how they are changing. So the plant model, we will represent it in a state space, we can represent as a state space model. That state space model, we will take it as a like a reference point. From there, we will solve the objective function with a set of constraint that will form your MPC controller. That controller will give signal, will calculate what could be the optimal states, and that states will give it to the plant for achieving the required states. Okay, so that is how a model predictive control work. In PID controller, it is not the case. PID controller will only take the current state of the system. It will have a desired set point. It will calculate the error and it will try to minimize the error and give you the desired output, which is not the case for all problem. Okay. So now how we write the state space model? We write the state space model in this way, where what is the X here? X is the states of the system. So k plus 1 is nothing but the further state of the system from the current state xk. And what is uk here? Input to the controller. Output equation is not written here, but output is y of k will be equals to c of xk and d of uk. So I can write that here also, but anyways this we will be doing it in more detailed way. So what are the A, B, C, D here, or A, B and all, what are those? These are the system matrices that we will calculate from the plant model. We will use the plant mathematical model and calculate this A, B and C, D, and these are the plant matrices that relate the input with the states and the output. Okay, so that we will see in maybe in the next class while modeling through MATLAB. So here we will close today's session, and we will continue in the next class. I'll tell you what is exactly going to be the next class, because today afternoon we are having MPC from another faculty, which already we have scheduled. My session I'll communicate to you later. But please be installed MATLAB, preferably 2020 onwards, and while implementing, install MPC control toolbox. MPC control toolbox. So thank you. Any question, any doubt? State estimator. That is the observer only. That is what, ma'am. State estimator is what? It will estimate from a set of measurement. Like you know, the position of the vehicle is something related with the speed. Exactly. It will measure the state. So we will estimate it. It may not be the actual one, but it will give you the most accurate estimation of the states. Yeah. Exactly. Anything? Y of k equals to yk plus I minus. Acha, okay, you are talking about the state space model? Okay, so if you want to write it that. Okay, fine. Don't worry, sir. I'll share the PPTs for your convenience. No problem. For the time being, you can write. Yeah, Sabas, you can just guide them.
Thank you, ma'am, for your valuable session. We are looking forward for your another session. So now we'll have lunch, but before that, I would request all the participants to make a signature in this attendance sheet. Right? There are some details unfilled here, right? Like university name, like affiliation, and email ID and mobile number. If they are filled, it's okay. If they're not filled, just I would request you to please make it handwritten. Thank you. I'll guide you to the lunch venue, okay, now after the signatures are done. Thank you.
Good afternoon, one and all. Welcome to the second part of today's session. And it's my pleasure and honor to introduce the speaker of present session, Dr. T. Vinay Kumar sir. Vinay Kumar sir has completed his BTech and MTech from Gian Hyderabad and PhD from NIT Warangal. Currently, he is an assistant professor at NIT Warangal. His area of research includes power electronic and drives, direct torque control, predictive torque control, open-end winding, induction motor drives, multi-level inverter, hybrid electric vehicles, and renewable energy interfacing. Vinay Kumar sir has around 45 publications, of which 27 are journal publications and 18 are conference publication. And he was awarded an Early Career Research Award by SERB in 2019 and also SIRE Fellowship Awards by SERB in 2022. Vinay Kumar sir has granted and completed 4 SERB projects, and under his guidance 5 PhD scholars has completed PhD and there are 2 ongoing scholars. And he is also a faculty advisor for Electrical Engineering Society. Thank you, sir, for accepting our request for delivering a lecture in today's session, and welcome to the session, sir.
Good afternoon to all. Now it is very hard time to me to transfer the energy. Now already 2:45, just now we had lunch, right? It is very big challenging for me to transfer the energy effectively, right? I will take care, no issue. In between I will try to ask questions, right? If you know, you can answer, otherwise I will see this session should be like interaction session. Don't feel it will go in one direction, right? So main object of today's session is we'll try to understand, see, first 30 to 35 minutes we'll try to understand what is the need of model predictor controller, right? This is very important. If you want break any pattern, important thing is you should know what is the existing pattern, right? What is the logic behind the existing system? We should know clearly. Once you know the existing pattern, right, in detail, right, if you want to do modification or if you want break the pattern, it is not a big challenging. See, now, see, by title itself will give 2 challenges. Now anyone see what are the big challenges with respect to model predictor control? Title, if you analyze the title in detail, you will get clarity about what is model predictor control. See, before discussing, before understanding what is model predictor control, how to use, particularly how to adopt this technique for motor drive control, right? See, first, what is model predictor controller? What is need of model predictor controller? We should know before starting the session. Now tell me, see, title is, it is reflecting. If you go analyze the title in detail, there are 2 challenges are there with respect to model predictor control. What are the 2 challenges? Design of the model. We are not designing any model here. You have to understand the model. You have to understand the existing model. Next. No. You forget about application. Anyone? There are 2 challenges are there here. Actually, model predictor is nothing but combination of 2 things. We are targeting 2 parameter. Yeah, okay. Prediction is a very big challenging. Any other? Control. There are 2 things are there. See, these 2 are very important parameter with respect to model predictor control whenever you want to adopt this technique, right? See, important thing is first you should know actual system characteristics. Without knowing the behavior of the actual system characteristics, what parameter we need to target with respect to electric drive, we don't know the control parameter, it is very difficult to adopt the model predictor control method. The big challenging in model predictor control is predicting the system behavior, right? At the same time, control the variable. You got my point? Model predictive control. First you need to take care about, see what is the status of the variable in the coming sample. You have to predict right? After that, after predicting the value, how we can optimize. What switching state we need to adopt to minimize the error is so challenging, right? Particularly in model predictor control. Now first I will try to focus on motor characteristics. This is very important. See, you all are electrical scholar. By taking this example, definitely you will get clarity about how to identify the parameter, control parameter or target parameter with respect to our system. So in today's session, our system is a motor. So for understanding purpose, initially what I will do is I will take DC machine so that you will get more clarity, right? Clear? If you know the characteristic equation of the particular system, it is not a big deal to identify the, see, if it depends on cause and effect, it is very easy to decide the control variable. You got my point? See, according to Newton's law, what is Newton's law? Newton's first law. Anyone? If you want change the state of objective, it required external force. Without applying the external force, we cannot do any job. You got my point? So here, if you take electric motor, if you take any electric motor, there are 3 circuits are there, whether it is a DC system or AC network, AC motor or DC motor, or even if you take special machines also, BLDC, PMSM or any machine. Finally, there are 3 circuits are there. What are the 3 circuits in electric motor? One is called armature circuit, another one is called field circuit, next mechanical circuit. You got my point? Our system is a dynamic system. Always, see, load is connected to the motor shaft. You got my point? See, even if you take DC machine or AC machine, finally our aim is, our objective is with respect to drive. What is drive? Drive is a basically mechanical energy producing device. By using motor, we can able to produce the mechanical power, right, effectively compared to IC engine or compared to hydraulic drives. If you adopt electric motor in drives application, right, we can control the speed, we can control the torque instantaneously. The beauty of model predictor control is instantaneous control is possible. Instantaneous control is so important in high performance drives application, wherever particularly in electric vehicle application or aerospace application or submarine application or in robotic application, instantaneous position control or instantaneous speed control is required. If you want to change the shaft speed or shaft position, essential thing is we don't have any freedom. You need to control only torque. Torque is the primary control parameter to change the dynamics of the speed of the shaft or to change the position of the shaft. If you want to change the position, what you need to control? How we can change the position? Now, there is a shaft is there. I want to change the position of the shaft. What it required? It required speed. Speed you have to change. By changing the speed, we can change the position. But speed, how it will change? What is the logic? Right? See, what is the main cause component to change the speed? Torque. Torque is the main cause component to change the speed. Right? So, right, torque is the primary control objective, particularly in electric drive system. If you take DC drive or AC drive or special machine also, if you take any electric motor, our target parameter is torque. Primary target parameter is torque. Why I'm particularly telling, see this one, control mechanism or feedback mechanism or feed forward control techniques, everything will come based on the system characteristics. See, if you are unable to understand the system behavior, it is very difficult to develop the control method. Control method, it will come. It is a simple subpart of the actual system. If you know the system behavior, if I know the student behavior in classroom in detail, mentally as well as physically, definitely we can change our modulating value. By changing the modulating value, we can transfer the energy effectively. Otherwise, without knowing the student characteristics, it is very difficult to transfer the energy. Clear? So the main object of today's session is, first I will try to go through the fundamentals, right? Why electric motor is in vehicle application. Next, how to identify the control variables in electric drive. Whatever variables we are going to identify, these variables are common for all electrical drives. Even if you take DC drives or AC drives or special machines also, control variables or target variables will not change. Our system is motor. What is the function of motor? What is the function of motor? Basic function of the motor? Basic function. What is the expected output of the motor? If you take any motor, expected output is torque. Torque is the parameter. Because of torque, you are getting speed. Because of the speed, we are able to control the position. You got my point? The basic primary element, right? The expected output of the motor is a torque. This torque is mainly because of the, what is the input to the motor? Voltage. Because of the voltage, right, we can able to control the current with respect to electrical circuit. By control the current effectively in electrical circuit, we can control the flux in magnetic circuit. By control the flux in magnetic circuit, what will happen at the end? See, magnetizing flux and armature current both will interact with respect to each other. It will generate the twisting force. Finally, see, if you take motor, any motor, DC motor or AC motor, it will produce the twisting force. Torque is the expected output. Now my question is, see, as an electrical scholar, the logic, whatever logic is there behind the electrical voltage, whatever logic is there behind the mechanical potential element, where torque is the mechanical potential element. If you want to produce the voltage, what it required, there is a common principle is there. Even if it is a DC generator or AC generator, what is the common principle behind to generate the EMF? What it required? There is a standard principle is there. Standard method is there. Standard, see, constraint is there. You have to fulfill that constraint so that we can able to produce voltage. What is the standard constraint? You need to maintain relative motion. No option. We don't have any option. If you want to produce the voltage, you have to provide relative motion, right? Whether it is a DC generator or AC machine or transformer also. Even if you take transformer, essential thing is you need to maintain finite relative motion, right? If you maintain finite relative motion between the magnetizing flux and conductor, you will get twisting, you will get electrical force. Clear? Now my question is how to generate what is the main constraint to produce the mechanical force? Torque is called mechanical potential element. If you want to do any job in electric circuit, it required voltage. Voltage is the primary component to do any work in electrical circuit, right? With respect to mechanical circuit, torque is the primary cost component to do the mechanical job. If you want to if you want pull or push, or if you want to lift the luggage or anything, it required mechanical force. Torque is required. Force is required. Now, see, torque is the main cost component in mechanical system to do mechanical job. Clear? Now, my question is very simple. If you want to produce the twisting force or torque, what condition or what constraint we need to satisfy? Anyone? See, finite relative motion is required whether it is a DC generator or AC generator. You need to maintain finite relative motion between the conductor and flux. Then only you will get EMF. EMF is mainly because of finite relative motion. Now my question is how to generate the torque. There is a standard. I am not asking about mathematical model. Later I will come. See, in today's session, I will try to focus mainly on mathematical model. I am not asking about mathematical model. I am asking about philosophy behind to generate the twisting force. See, if you want to produce twisting force or torque, whether it is a DC machine or AC machine or synchronous or asynchronous machine or special machine, essential thing is you need to maintain zero relative motion between magnetizing flux and armature flux. This is a very important point which is common for all electrical motors. If you maintain this condition, right, definitely here twisting force is a finite value. If you are unable to satisfy this constraint, there is no output force, output torque in machine. You got my point? See, I will repeat once again. If you take any motor, at any instant of the time, you need to take care about what is this speed difference between magnetizing flux and armature flux. Relative motion. This relative motion must be zero. Right? See, in case of DC machine, armature flux is always in the pole axis. Magnetizing flux is always in phase with pole axis. Armature flux is in phase with brush axis. Right? With respect to each other, both are looking like stationary. You got my point? So if both are looking like stationary, then only both will interact, it will generate the twisting force. Even in case of induction motor, even though it is a asynchronous machine, magnetizing poles and rotor both are not rotating at same speed. Rotor conductor speed and magnetizing poles speeds are different. You got my point? But even operating speed of the rotor and speed of the magnetizing poles are different, but if you see the relative motion between the magnetizing flux and armature flux produced by the rotor conductor always matching with your supply frequency. You got my point? Speed of the stator pole is matching with supply frequency. Speed of the rotor pole is also matching with stator frequency at any moment, right? So if you verify the relative motion between the stator flux and rotor flux, it is always 0. Even if you take synchronous machine at any instant of the time, under steady state condition, NS and NR, see rotor poles, speed of the rotor poles and speed of the stator poles, relative motion is 0. Why there is no starting torque in case of asynchronous machine? Reason is initially, right, there is a finite relative motion is there between stator poles and rotor poles. Initially, if you take synchronous machine, your rotor poles are stationary, but stator poles are rotating with 1500 RPM. So if you verify the relative motion between the stator pole and rotor pole, there is a finite value is there. Because of this reason, your machine is unable to generate the twisting force. If you want to produce the twisting force, mechanical potential element, essential thing is 0 relative motion is required. The beauty of commutator in DC machine is it will take care. In case of DC machine, your commutator will take care about the relative motion between the stator flux and rotor flux. It will maintain, it will take care. You don't need to do anything. Even if you take asynchronous machine, induction motor, you know about slip? S. Slip will take care of everything. I will tell. Best example, what is the speed of the participants? 0. You all are stationary, right? So what is the speed of what is the speed of speaker? 0. Right? What is the relative motion between participants and speaker? 0. With respect to each other, relative motion is 0. That's why we are interacting. Otherwise, if participants are stationary, if speaker is running with some finite speed, interaction will there is no, I cannot transfer the energy. You got my point? Otherwise, speaker is stationary, participants are running with some finite speed, no interaction. You got my point? At any instant of the time, whether flux is rotating or flux is stationary, magnetizing flux is stationary or rotating, right? See, relative motion between the stator flux and rotor flux must be 0. Clear? If you clear this one, definitely you will get clarity about the how to identify the control variables. Our second topic is identify the control variables in electric drive, right? Then after that, what type of electric motors they are adopting in a vehicle application we'll try to discuss in detail. Then classification of speed control techniques. Next, design of control parameters. Particularly, I will not go in detail. Particularly, see, our main objective is understanding the philosophy behind the predictive control scheme for electric drives application, right? Next, what is the main motivation for MPC method? What is the basic difference between conventional PI controller and model predictive controller? I will try to explain in detail in today's session. Next, what are the classification of model predictive control method? What is the significance of finite control method? Why finite control method, finite control set method become so popular in industrial application as well as research point of also many scholars they are adopting finite control set method, right? Next, after that, simulation studies we'll try to discuss in detail. Next, what are the challenges in MPC scheme? We'll try to. This is all the content of today's presentation, right? See, electric motor is a part in the part. It is drive is nothing but see motor, controller, power converter, feedback, everything is coming under drive. Drive is a, see, it is a very mechanism, big mechanism. How many of from electronics? Many participants. Then it is very challenging for me again. Sorry, computer science also. Oh, if it is very challenging for me to transfer the energy to the computers as well as electronic scholars. If electrical, see, my focus is on control only. See, please try to understand. No problem. If you are having any basic doubts, you can ask. My question is, many, that's why I'm telling, many scholars, they're worrying about, see, how to develop the control system, how to develop the, how to understand the model predictive. They are worrying about the control mechanism, but they are not focusing on the system. I'm telling, important point, let us assume that there is a 1 hour time is there for you, right, to develop control logic. Please try to understand, 45 to 50 minutes you have to spend for understand the characteristics of the actual system. If you know the behavior of the system, characteristics of the system in terms of mathematics, in terms of characteristics, in terms of, right, everything. If you know the in detail behavior of the system, it is not a big deal to, within 5 minutes we can develop the logic, control method. You got my point? Clear? So what I'm doing here, first I'm trying to explain the system behavior. My focus is, if I enter directly to the model predictive controller, if I explain the model predictive controller with respect to induction motor or PMSM machine, participants will run like anything. They cannot understand. So see, what I'm trying to is, see what is the need of model predictive control. If you want to develop control logic, first how to identify the target parameters. This is very important. What parameter we need to control. Without knowing the control parameter, it is very difficult to develop the logic. You got my point? Next, one more important thing is, if you take any system, if you want to develop control mechanism for system, right, without knowing the control variable, we cannot develop the hierarchy. You got my point? Building the hierarchy is a very big challenging for electrical scholars or any scholars, right? Clear? You know about hierarchy, control hierarchy. What is hierarchy? Sequence. Take best example, institutes. If you take any institute, even if you take NITs or IITs, or even if you take private university also, they are following standard hierarchy. Everyone is adopting standard hierarchy. What is the hierarchy? Students are controlled by the faculty. Faculties are controlled by the HODs. HODs are controlled by the deans. Deans are controlled by the director. You got my point? But actually, who is working really? What is our target parameter? This is the sequence. Student and faculty is most inner loop. Am I correct or not? That is called most inner loop. Then after that, what is the loop? HOD loop. Right? Then after that, what is the loop? Deans. All deans are working under. So who is most outer loop? Director. Now, see, actually, if electrical scholars are there, I can explain in terms of bandwidth. You know about bandwidth? What is bandwidth? I'm not asking definition. What is the significance of bandwidth? Suppose there are A and B students are there. If A student bandwidth is 1000 hertz, if B student bandwidth is 2000 hertz, what will happen? The ability of the B student extracting the, or what is the ability of the B student? If B student bandwidth is more, ability is he will track the reference very fast. You got my point? He is having more ability to track its reference. Within short period, he will understand the concept. It will not take delay. But A student, bandwidth is very less. If bandwidth is very less, we don't have any option. You need to adopt control mechanism. The beauty of control system is, by adopting the control mechanism, we can able to improve the bandwidth of the actual system. By nature, most of the systems offer less bandwidth. We don't have any option. By nature, if you take any system, right, it will offer poor characteristics. Nothing but with respect, all systems practically all are in lazy condition. Lazy nothing but that is the nature. Pole position of the system are very closely to origin. If pole is closely to origin, issue is, what is the issue? You know about pole zero at least? Control system? Then tell me. If pole is, by nature, if you take any system, what is the need of control mechanism also we have to understand. By nature, if you take any system, right, pole is always, dominant pole is closely to origin. If pole is closely to origin, issue is system will not respond immediately. You got my point? Whatever input you are giving, even if you apply some force, your actual system will not respond immediately. That's why it required control mechanism. By adopting the mechanism in proper, by using proper sequence, definitely we can improve the bandwidth of the system. So if system bandwidth is improved, what is the advantage? If system bandwidth is improved within short period, your system will reach to steady state. You got my point? It will not take much time. Immediately your system will reach to your reference point. Whatever speed you required, your system will respond to your reference value. Clear? So that's why I'm telling in today's session, by taking one example, I will try to explain what is the significance of controller. Without controller, with controller, mathematically I will try to explain so that you will get more clarity about what is the need of feed forward controller. Feed forward controller is very important controller, right? But where we need to adopt this controller is very important. If you want to adopt some control mechanism, first you should know whether this feed forward control or model predictor control really it is required or not. You should know. You got my point? Whether need is there or not, you need to get more clarity. As a scholar, you should know whatever method you want to adopt, whether that method will give the required response or not. You have to justify, right? So this slide will give the significance of electric motor compared to IC engine. By taking various parameters, right, we can identify what is the importance of electric motor in application, right? See, even if you take IC engine or even if you take hydraulic engine, basically all are mechanical energy producing device. You got my point, right? Instead of taking IC engine, if you take electric machine, what is the advantage? What is the advantage with electric machine? If you replace IC engine with electric machine, that's why electric vehicles become so popular. If you observe one parameter, bidirectional, there is one parameter is there that is called bidirectional. With respect to bidirectional, what is the advantage if you adopt electric machine in vehicle application? Bidirectional power flow. Nothing but, see, same machine, it can operating in generating mode also. Whenever you want to apply brake or whenever braking mode is required or deaccelerate mode is required, the ability of the electric machine is it will enter in generating mode. But your IC engine never will enter in generating mode. You got my point? So once your drive is entering in generating mode, your power is feeding back to the source. During deaccelerating mode or braking mode, we can charge the auxiliary batteries in electric vehicle application. That is the significance of electric machine. That is the ability of electric machine. One more important point is, see, efficiency of the electric motor compared to other drives, it is more than 90%. Efficiency is more, what is the advantage? If efficiency of the drive is more, what is the advantage? Anyone? That is fine, losses, okay. Heating effect is less. With respect to system point, if efficiency is more, heating effect is less. If heating effect is less, advantage is you can operate more period. Reliability, it is completely depends on how much efficiency offered by the particular system is so important to decide the continuity of the operation. How much speed you need to operate, electric vehicle will decided by the heating effect. If heating effect is more, right, you have to stop the vehicle or you have to use some forced cooling methods. You got my point? See, efficiency will decide. Efficiency is a factor. How much energy is converting from one form to another form will decided by the efficiency factor. Remaining energy is decided, remaining factor 10.1, efficiency 90%, remaining 10% is converted in terms of heat only. You got my point? So see, by using efficiency factor, by using bidirectional parameter, we can highlight electric machine compared to conventional engines, combustion engines. So here now this is complete hierarchy of the electrical propulsion system. If you take any electric drive, this is the standard block diagram, not only for electric vehicle application, even if you take robotic application or aerospace application, they are following this structure. See, our focus is here. What is our focus? Our main focus is on, I will just in a minute pointer. See, our focus is on this one here. So this all are under software side. What are the things are there under software? Control methods. All control methods are coming under software side. This, see, whenever you want to develop some logic, right, through mathematics, we can do. Whatever equations you have developed to control the actual system, that equations you have to execute through hardware, controller, microprocessor or microcontroller or DSP or FPGA boards. By using control boards, we can execute our logic. Then after executing, if you take any electronic circuit, right, what is the expected output of the controller? Any controller. What it will give? Controller output. This one, take DSP. What is the output of the DSP controller? It will give control pulse. It will give gate pulse. You got my point? That gate pulse will apply to the power converter. Switch. What is the advantage of the switch? Power converter, nothing but inside there are switches are there. By adjusting the on and off period, what we can do? We can control the energy transfer from source to machine. By control the energy transfer from source to machine, we can control the characteristics of the actual system. By changing the characteristics of the actual system, right, we can satisfy the load. Our top priority is meeting the load requirement. To satisfy the load requirement, as a design engineer, you have to select the proper control method. By selecting the proper control method, we can able to control the energy transfer from source to machine. We can control by control the energy transfer from source to electric motor, right? We can control the torque speed characteristics of the motor. By control the torque speed characteristics of the motor, we can control the speed of the wheels. We can satisfy the customer. This is the standard procedure, right, for any electric drive system, right? Even if you take aerospace application or electric vehicle application, they are following this method. In today's session, our main focus on control mechanism. So see, I think for electronics students, they have not studied, I think they don't have transformation technique. You have not studied transformation techniques, right? Electronics or computer science. It is very, no, transformation, 3-phase to 2-phase transformation. It is very difficult to, why? Because see, nowadays no one is using DC drives, right? All are adopting AC drives. Problem with AC drives is minimum 3 phases required, or right? So optimal number of phases with respect to AC is 3 phase, right? If your actual system is in 3-phase model, right? Whenever you want to control the 3-phase system, it requires transformation techniques. But model period to control everything is based on transformations only. Anyway, I will go very slowly. I will try to explain. How many electrical scholars are there? Can you raise your hand? So that 1, 2. Electrical. 1, 2, 3, 4, 5, 6. Okay. Anyway, I will go very slow. I will try. I do. Next. Oh. See, my area of specialization is power electronics and drives. Hmm. See, please try to understand. See how they are adopting the model predictor control in electric drives. Try to understand. Same thing you can apply to your system. System to system, what will happen? Characteristic equation will change. Target parameter will change. You got my point? So based on your system characteristics, as a scholar, you need to identify what are the target parameters. Once you know the target parameter, see, you need to identify what is the hierarchy to control that parameter. If you know the hierarchy, it is not a big deal. Clear? At least if you know the fundamentals of DC machine and AC machine, it is easy for me to transfer the energy effectively. So here our main target parameter is, so main object of today's session is control, model predictor control. So with respect to controllability point of view, right, if you compare the performance of DC machine and induction motor or other machines, so with respect to controllability, DC motor got highest point. But other all machines, induction motor, PMSM, SRM, hybrid machine got less. Maximum marks 5. DC motor got 5 out of 5, but other machines got less than 5. Now my question is, why controllability of the DC motor is very good compared to AC drives? What is the reason? How to decide the controllability? That's why I'm telling. If you understand in detail about the actual system, it is not a big deal to identify the controllability, power density, efficiency. Everything will come based on the actual system behavior or characteristics. Clear? So what I will do is I will try to take simple equations, so that based on simple equation I will try to explain, so that you will get at least minimum 50 to 55% concept. Even if you understand delta x is also fine to me, no issue. Clear? Now tell me here, why DC machine with respect to DC machine, this one, with respect to controllability point of view, DC motor got 5 out of 5. Construction, no. How to decide? How we can decide? See what is the main parameter? See, will decide the controllability of the system. Very good, torque. So controllability, it is completely depends on the torque profile. Clear? Torque generated by the machine, based on the torque profile we can understand the controllability. Why? Because see, whenever you want to understand the behavior of the system, or whenever you want to decide the performance of the system, see, with respect to student, how we are deciding the performance based on the CGPA. After writing examination, after evaluation, right, we are giving the grade to the students. Based on the grade, we are identify the we can classify the students. So CGPA is the main parameter. With respect to CGPA parameter, we can classify the performance of the students. We don't have any other option. Am I correct or not? So with respect to, right, our system is a motor. With respect to motor point of view, right, controllability is decided by the output parameter of the system. Output parameter, if you take any machine, motor, expected output is torque. Based on the torque profile, we can decide the controllability. Right? So this is called, this is called universal torque expression, which is applicable to all electrical drives, all electrical machine. Right? Even if you take DC machine or AC machine, this equation is applicable for all electrical. That's why it is called universal torque expression, potential equation for all electrical machine. Right? In case of DC machine, the beauty of DC machine is by adopting the commutator, we can maintain delta, How much in case of DC machine? 90 degree. If it is a 90 degree, then so this one sine delta become 1. What is the advantage? See, so how many variables are there in torque expression? There are 2 variables. If delta is a variable or constant. In case of DC machine, by taking care about the armature reaction effect, at any instant of the time we can able to maintain delta 90 degree. Throughout the operation we can maintain delta 90. If delta is delta 90 degree, see the number of variables involved in the torque expression will coming down. If number of variables are decreases, advantages with respect to control point of view, burden on the controller will coming down. You got my point? So here how many variables are there? 2. Delta is nothing but angle between stator flux and rotor flux, where delta is the angle between these 2 flux, right? Now see what is the order of this equation, how to decide order? What is the order? What is the order of this equation? Order is it is a second order system. But now my requirement is I want to control the torque instantaneously. Second order is a linear or non-linear system? It is a non-linear. Non-linear systems, by using non-linear system, we cannot expect, you should not expect high performance. Even though it is a second order system, if you want to improve the dynamics instantaneously, it is not possible. In case of DC machine, by nature, it is in non-linear condition. But good thing is number of variables are only 2. You got my point? So you know about armature voltage control method? In armature control method, see throughout the operation we are maintaining stator flux constant. If stator flux is constant, advantage is second order equation will convert it to first order. So here we are not changing any physical parameter, we are not replacing something, or we are not adding, or we are not modifying with respect to physical point of view. Only thing is mentally, see, by adopting the control mechanism, by using armature control method, what we are doing is we can change the characteristics of the actual system. By applying the armature control method, what is happening? It is a technique, engineering technique. You got my point? So by adopting armature voltage method, see the characteristics of the motor, we can convert it from non-linear to linear. Now what is the advantage? If it is in linear mode, if it is in first order, what is the advantage? We can change the torque. We can able to control the torque instantaneously. If number of variables are more in your mind, it is very challenging for me to transfer the energy. If there is only one variable is there in your mind, it is very easy. Instantaneously I can able to transfer the energy. You got my point? What I am trying to say, if number of variables are more, it is very difficult to control. If number of variables are more number of feedbacks are required. If number of more feedbacks are increases, number of PA controllers, or even if you take model predictor controller, what will happen? Target parameters will increases. You got my point? Now here what we are doing here, if you understand this point, definitely we can understand the model predictor control with respect to motor. I am telling, see, even if you take DC machine or AC machine, right, control the torque principle philosophy, it is common for all electrical machine. Don't think DC motor control principle is different, AC motor control is principle is different, or special machines principle is philosophy. See, concept is same concept, but execution is different. Methodologies are different. Based on the number of variables, right, we are changing the method. In armature control method, DC motor, we are focusing on only field current. By controlling the field, right, by maintaining, right, IF field current constant, advantage is non-linear system become linear. If it is a linear mode, instantaneous control is possible. Instantaneous torque control is so important in high performance application, electric vehicle application, aerospace, robotic application. See, their requirement is torque, right? they want to control instantaneously. If torque is controlled instantaneously, we can control the position or speed instantaneously, right? Now here, if there are two things are there. What we are doing here, tell me if you understand this one. Now we are, see where torque is the expected output of the motor, where torque is the potential element, right, produced by the motor. By using this potential element, we can do mechanical jobs. Am I correct or not? Now thing is, see now with respect to torque profile, how many target parameters are there? With respect to motor side, how many parameters we are targeting? Initially, before controlling the torque, we are controlling the flux. You got my point? We are maintaining field flux constant. Initially, we are controlling the flux. So by controlling the flux initially, by maintaining the field flux constant initially, advantages torque control become very simple. Whenever you want to teach the concept to the students, first you have to create good environment. Am I correct or not? See, if you take any machine, electrical system, if you want to do any job, it requires reactive power. Reactive power, what it will do? It will provide the environment to do real job. If you want to do real job, if you want convert electrical to mechanical or mechanical to electrical, it requires reactive power. Reactive power will provide environment to do actual real job, right? Here also, right? See, by controlling the field flux, by maintaining the field flux constant, torque control becomes simple. So as an electrical scholar, whenever you want to control the torque, initially you need to control the flux. So finally, what are the target variables? Our target variables are two. One is torque controller. Torque is the primary objective. Second control parameter is flux. So, right, even if you take conventional methods or conventional PA control based methods or model predictor control method, our target parameter is torque and flux. How we are going to control the torque and flux, particularly in electric machine, right? Now finally what we identify the control parameters. Once you identify the control parameter, next immediately you have to identify the hierarchy. You need to decide the hierarchy. What hierarchy we need to follow? Whether it is a PA controller base or whether it is a model predictor base, you need to identify the hierarchy. Identify the hierarchy is very important, right, to control the parameter effectively. Otherwise it is not a possible. It is, if you are not following hierarchy, we cannot transfer the energy effectively. We cannot change the characteristics of the motor based on the load requirement, right? Now if you take induction motor, what is the order of the induction motor? Now electrical scholars, you can respond. Electrical scholars are there, right? Now what is the order of the torque profile of the induction motor? You forget about now number of electrical scholars are less. I will not go in detail about synchronous machine. I will take only two topics. These two topics, with respect to these two topics, I will try to complete my session today. Now tell me, what is the order of induction motor? In case of induction motor, no brushes, no commutator. Clear? Then delta is not a constant. It is a variable. In case of induction motor, delta is a variable. This is also variable. Next, lambda r and lambda s is also variable, but where lambda s is nothing but resultant stator flux due to A phase, B phase, C phase. Inherently, there are three components are there. Similarly, rotor side, A phase rotor flux, B phase rotor flux, C phase. It is a three-phase system. So, see, if you take lambda s, it is mainly because of interaction of the three stator flux. Lambda r is also interaction of the resultant of three rotor flux. So 3 plus 1. So what is the order? 7th order. You got my point? Now you can think, if number of variables are more, what is the issue? Control is difficult. More number of feedbacks. If you want to control the torque, you should know, right? A phase, B phase, C phase stator flux information, right? Rotor A phase, B phase, C phase flux rotor information is required. With respect to lambda s, 3 feedback signals are required. With respect to rotor side also 3 feedback signals are required. Next, space displacement angle between stator flux and rotor flux is also required. Why? Because it is not a constant. It is regulating instant to instant based on the operating frequency, based on the supply voltage, right? If there is any disturbance is there suddenly on the shaft, definitely delta will regulate. So number of variables are 7. Now control complexity is more. But my question is, why industry people? If you take any industry, all are adopting induction motor. 85 to 90% electrical drives are operated with induction motors. What is the reason? Even if you take Tesla car, initially they adopted induction motor for traction purpose. In electric with respect to controllability point of view, with respect to torque profile, DC motors are very strong. Now example I will take. Let us assume that there are two students are there in the class, right? A and B, right? So mentally A student is very good, technically is very strong, right? Whatever you are teaching, he will understand within short period. Mentally he is very strong. A student, expected grade in the examination is excellent. But B student, right? See, mentally he is not strong. Expected grade in the examination is C or D, you can expect. But thing is, the problem with A student is physically he is not fit. Physically he is not fit because of some health issue. He cannot run fast, or he cannot sit in the exam hall continuously half an hour. More than half an hour he cannot sit in the hall, exam hall, because of physical fitness. Then see, so expected grade is A, expected grade is excellent. B expected grade will take C. Assume that mentally he is not strong, but physically, see, what is the exam? Let us that exam time period is 3 hours. So after getting the question paper, the ability of the A person is he can answer all 5 questions. He can respond 5 questions. But issue is he cannot sit in the exam hall continuously 3 hours. More than half an hour he cannot sit. Why? Because physically he is not good. B student, the ability of the B student is he can sit in the exam hall continuously 3 hours. But what is the problem with B? He cannot attempt all questions. Only 45 to 55% he can answer. But who will get grade after examination? After examination, who will get grade, B or A? Hey, after the ability of the A is he can attempt all 5, but he cannot sit in the, he cannot write exam continuously. More than half an hour he cannot sit. Right? So who will get grade? B will get C grade. So placement people, they will select C. Am I correct or not? Placement people, they will select B person. So what is the challenging? After that, what is the big challenging? After selecting the B person with respect to company point of view, industry point of view, what is the big challenging? Their target parameter is physical parameter or mental parameter? Mentally they will train the B person. They will try to improve the mental characteristics of the B person. Similarly, with respect to electric drive, DC motors mentally very strong. Torque profile, order is in second order, but induction motor order is 7. Dynamic response is very poor. Mentally very poor, but induction motor lifetime is 70 to 80 years. If you want, you can operate continuously more than 3 months, 4 months, nothing will happen. But DC motor, we cannot operate more than 40 hours or more than 24 hours also we cannot operate with maximum load. Right? Reason is, what is the problem with DC motor? Commutator is the weakness. The strength of the DC motor is commutator, weakness is also commutator, both. So here A person is nothing but, with respect to our example, DC motor. B is nothing but AC motor. The ability of the AC motor is it can run more hours. Reliability, maintenance is 0. No brushes, no commutator, it doesn't require maintenance. The ability of the induction motor is it will occupy very less space. Particularly space is a main constraint in aerospace application, electric vehicle application, in submarine application. There is a limited space is available for mechanical energy producing device. You got my point? There is a limited space is available for drive part. If you take DC motor, it will occupy more space. Clear? Understood? So that's why here issue is, here the object of this slide is, by using this slide we can understand what is the significance of AC drives. AC drives mentally very poor but physically very strong induction motor. So by adopting the control mechanism, by adopting the model period control method, we can improve the mental profile. How we can improve the mental profile? Right? By using engineering technique. You have to adopt technique, armature control. By adopting the armature control method, what happened with respect to DC drive? Second order system is converted to nonlinear, system is converted to linear. Similarly, see, there are advanced vector control methods are there. Model P2 control will come under vector control technique, advanced method. By adopting model P2 control method, what will happen? Higher order system, seventh order system will convert it to first order. You got my point? So, see, after adopting some mechanism, after adopting some technique, engineering technique, mathematic technique, as well as by taking the combination of power electronic module, by combining these two, right, we can able to change the characteristics of the B person similar to A. You got my point? We can change the characteristics of the induction motor similar to DC motor. DC motors are called benchmark machines, but practically these machines, they are not adopting, they are not using DC motors practically, but they are taking as a benchmark with respect to torque profile or with respect to performance wise, right? All industries, they are taking DC motor as a benchmark to improve the excellent student. See, what is the benchmark in class? A person is a benchmark, clear? But he is unable to write the examination. So here, how we can improve these are all the challenges. If you take AC drives, right, main thing is you need to take care about the nonlinear component in the torque expression. See, with respect to drive system, see, torque profile is a very important. So same thing, whatever system, see, whatever work you are doing for particular system, you have to identify what is the potential element with respect to your system. You got my point? What is the expected output of your system? You need to identify potential element. See, if you identify the potential element of your system, right, it is not a big problem to identify the order of your system. If order is less, control ability is very good. If order is more, control become very complicated. But induction motor, order is more. Torque profile is very poor. Number of variables are more. That's why, see, eliminating the nonlinear component in torque expression is a very big challenging. Right? If number of variables are more, control complexity is increases. Control complexity is more, what is the issue? It requires a lot of instructions. Right? If number of instructions are more with respect to computer science point of view, if number of instructions are more, what is the issue? We cannot take more number of samples per second. You got my point? We cannot take more number of samples. If you take more number of, see, let them that, see, instruction, particular instruction, if you want to execute, 1 microsecond is taken. Same instruction, same method, we can write with lengthy program also. Right? Instead of taking 1 microsecond, let them that second program is taking 10 microseconds. What is the issue? Number of samples are coming less. If number of samples are less, you will lose accuracy. Clear? Here also, once accuracy is decreases, definitely steady state characteristics will get effect. Steady state performance is completely depends on, see, what is the percentage, how many samples, what is the execution time of your logic is so important. Execution time is how, see, now how to decide the execution time based on your instructions. Right? Once you know the execution time, it is not a big deal to identify the sample time of the system. Whatever sample you are taking, that sample time should be always greater than the execution time. This is a very fundamental principle common to any electrical engineering, whether it is whether it is electrical engineering or electronics or computer science. Basic principle is right? Whatever sample you are taking, whatever sample time you are taking, within the sample time, you have to complete the task. You have to execute the logic. After executing the logic, you will get some output parameter. You have to store somewhere else. You have to store some, right? You have to store the data. Sample time, it is fixed. It will not vary. Sample time, it is not under your control. Sample time is decided by the execution time. Execution time is decided by the how many instructions are taking to control the variables. It is completely decided the length of the program. If length of the program is more, execution time is more. If execution time is more, let us that execution time is 1 microsecond, sample time you have to take more than 1 microsecond. This is thumb rule. Otherwise, let us that, see, if you take sample time 1 microsecond, but execution time is 1.5 microseconds, what will happen? What is the issue? After completion of the sample time, there is no execution, you have not completed the task, what will happen? There is no signal to the power converter. There is no signal transfer to the power converter. If there is no signal to the power converter, what will happen? Energy we cannot control. See, after completion of the sample time, right, see, your system is expecting the control pulse. Your power converter is expecting the control pulse from the controller. There is no output from the controller for particular sample. Definitely your system, we cannot meet the load requirement. Please try to understand. See, sample time, in general, they will calculate based on the execution time. First, you should know what is the time taken for completing the task. You should know, right? See, based on the execution time, we can decide the sample time. You got my point? Sample time should be always greater than the execution time. Sample time, it is not under your control. Execution time is under your control. You got my point? Same logic, if you write with less instructions, we can minimize the execution time. If execution time is decreases, proportionally you can minimize the sample time. No, I'm not, it is not a fix. See, based on, suppose, now my aim is control the induction motor. Suppose you take some scalar control method, execution time is 1 microsecond, sample time you have to take more than 1 microsecond. Throughout the operation, that time is fixed. Clear? Sample time, right? Initially, you have to, sample time you have to define. How to define the sample time? Based on the execution. See how much time is taking to get the information is so important. Once you know the execution time, it is easy to decide the sample time. Clear? Now, these are all the methods, these are all the techniques to overcome the challenges whenever you want to improve the profile, student profile or physical motor profile. These things are standard things. So what is the first point? Understand the machine behavior. You have to understand the system behavior through mathematics. I am telling mathematics, many scholars, computer science or electronics or electrical scholars, they are thinking about mathematics. It is a subject. Please try to understand, it is not a subject. It is a language to understand the behavior of the system in detail. Right? Instead of reading 2 pages or 3 pages theory, if you analyze the one equation in detail in different direction, right? Definitely you no need to read 2 or 3 pages theory. You got my point? We can save time. We can understand the concept in detail if you adopt equation. Mathematical model, nothing but it is a technique. That's why mathematics, it is not a subject for engineering. It is a language. Each and everything. Good thing for electrical engineering is for each and every concept we can express in terms of mathematics by taking some approximation. You got my point? We're having proof. All machines or all systems, electrical system, we can represent in terms of mathematics. Model, that is nothing but modeling of electrical system. Once you know the mathematical model of particular system, we can easily extract the characteristics. Once you know the characteristics, we can easily identify the application, right? So next, another important technique is transformation. Transformation with respect to, see our system is a 3-phase system, but Here, whenever you want to control the three-phase variables, it is not a simple task. See, before explaining the transformations, I want to show one picture. This one. This picture will give significance of the transformation technique. Anyone? What is the significance of this picture? What is the application of this? This is engineering technique. It is also very popular. Wherever sharp curve is there, particularly in the hills area, they are adopting this technique, engineering technique. Now tell me, what is the purpose? What it will do actually in a particular application? What is the primary object of this mirror? This is called corner mirror. Generally, they are adopting corner places. Wherever sharp curve is there, they are adopting this mirror. What is the primary object of this mirror? What it will give? Let us assume that there is a one person. Let us assume that our reference person is coming from, see, left to right. If there is any vehicle is coming from right to left, then through this mirror, our reference person can able to identify if any vehicles are coming opposite or not. He can get the information. The primary object of this mirror is getting information about the opposite vehicles. Once you know the information about the opposite vehicle, what is the advantage? We can control the speed of the vehicle. If there are no vehicles, you no need to control. Even though it is a sharp curve, you can reduce the speed and you can move. Right? If there is any big vehicle is coming opposite, right? Heavy load vehicle is coming, you have to stop. Any vehicle, any car is coming, small vehicle is coming, you can reduce or you can go side and you can see. Advantage of the primary object of this mirror is it will give information. See, based on the information, what we are doing, we are controlling. You got my point? There are two things are there. Getting information is so important before control the system. Many scholars, they are not following these things. That's why it is taking delay to executing their problems, their research problem. Whenever they are working on some research problem, why it is taking delay? They are not concentrating on these two things. They're focusing on always control. They are forgot about how to extract the information from the actual system. They are forgetting. They are not concentrating on getting the information. You got my point? So this transformation technique will give information about the actual system in terms of two-phase variables. By adopting the transformation technique without losing any property, right? There is no change in the actual system information. Right? Whatever information is available in three-phase system, same information, right? It will give using two-phase variables. Right? So this mirror, anyway, right? This mirror will give information about the actual system. Once you know the information, we can easily control. Control, it is not a problem. Please try to understand. That's why I'm telling. See, within 1 hour, if you want to execute your logic, 45 minutes you have to spend for extracting the information or understanding the system behavior. Once you know the system behavior, characteristics of the actual system, it is not a big deal. Once you get the information through feedback, right, it is not a big deal to control. But many scholars, they are worrying about control. Sir, I am unable to get the results. Issue is they are not understanding the actual system behavior. Their feedback system is not working effectively. Right? So, this is about transformation technique. So, by adopting this transformation technique, what will happen? See, whatever information is available in three-phase system, this is about three-phase system. Actual system is always in induction motors or special machines, synchronous machines, always in three-phase only, practically. Right? So, using three-phase variables, it is very difficult to develop the control logic. That's why what they are doing is, they will apply Clark transformation technique. It is a method, mathematic technique. By applying the Clark transformation technique, what will happen? Three-phase variables will convert to two-phase. But here issue is still your variables are in AC nature. Why variables are in AC? What is the reason? Why three-phase? You forget about Clark transformation. Now I want to ask one fundamental question. Why our signals are always AC? Anyone? why we need to apply alternating voltage to the motor? Take induction motor or synchronous motor or special machine. If you take any machine, why we need to apply alternating signal? Basic principle. What is the see? When we need to apply AC, when we need to apply DC, there is a concept is there. Standard principle is there. When we need to apply AC, if winding is stationary, if coil is stationary, you need to apply alternating. Then only you will get voltage. Then only you will get back EMF in the coil. Back EMF is so important to convert the energy. You got my point? So, in case of three-phase, if you take induction motor or synchronous machine or special machines also, BLDC, PMSM, any machine, our stator winding is in stationary condition. If coil is in stationary condition, we don't have any freedom. You need to apply alternating signal. Then only you can able to produce back EMF. Clear? Now, here with respect to control point of view, right, this alternating signal is unwanted nature, right? So that's why later what they adopted Park transformation technique. By applying the Park transformation technique, what will happen? Two-phase variables are converted into two-phase DC. Now, even signals are converting from three-phase to two-phase AC or two-phase AC to two-phase DC. See, information it is not losing. Whatever information is there in three-phase system, natural system or actual system, same information you will get even your variables are in DC nature. You got my point? So what is the nature of magnetizing flux here? What is the nature of flux here? Rotating. What is the nature of flux here? Rotating. What is the nature of flux? Resultant flux, air gap flux? Rotating. In all cases, right, the behavior of the magnetizing flux is not changing. Flux is rotating in nature. So concept is, we are not missing any concept. But signals we are converting from three-phase to two-phase. We are converting. This is an engineering technique, mathematic technique. Mirror is a engineering technique. By adopting the mirror, right, you no need to get down and you no need to verify who is coming opposite or not. We no need to get down or we not. Simply, your job is, see, by adopting the mirror, we can monitor the, you have to check the image, right, so that immediately we can control. Clear? Understood? So, now my question is, why DC signals are required with respect to control point of view? Before discussing model predictive control, see, you should know what is the nature of control variables. Anyone? Why DC signals? You're asking something. Sorry? No. See, your feedback signal is in DC nature. Advantage is, what is the advantage? Our reference is always DC. Reference is DC, feedback is also DC nature, error is in DC. If error is DC, button on the controller become very simple. Only you need to regulate the magnitude. Otherwise, if error is AC, right, even reference is DC, finally your signal is in alternating nature. Right, in that case, you need to take care about magnitude and phase. Position, you need to control. But if error is in DC, only magnitude you have to concentrate. Button on the controller become very simple, very less if your actual signal or feedback signal is in DC. You got my point? So, practically, even though your system is in AC nature, right, with respect to control point of view, by adopting this transformation technique, what will happen without losing any property? See, we are converting AC signal to DC. Once your signals are in DC with respect to control point of view, right, then it is easy to regulate the magnitude. By choosing proper Kp and K values, we can regulate the errors effectively, right? So, see, this is the example. By taking this example, we can understand. See, even your inputs your actual system inputs are 3-phase in nature, alternating nature, right? What is the net power? Resultant power produced by the 3 phases 300 old amp. Even after applying the combination of Clark and Park transformation, right? Even 3-phase signals are converting into 2-phase DC, right? Is there any change in the net power? Information, there is no change in the information, right? This technique, what is happening, it is converting the signal, but it is carrying same information. You got my point? Break also. Okay, just a minute. You got my point? See, our topic is model. Before entering into model predictive control, see what we have done till now. We identify the control parameters. What are the control parameters of our system? Torque and flux. These two are the target parameters, right? So, see, whenever you want to control the torque and flux control parameter, see what is the problem with our system? What required your control system? We identify our system is AC system. Why we have taken AC system? What is the advantage of the AC system? Also we discuss. We have taken A and B example students. B student physically very strong. Induction motor is physically very strong but mentally weak. By adopting the control technique, we can improve the profile. We can improve the characteristics. Mentally we can improve. If student is not physically fit, as a faculty I cannot do anything. But if student is mentally poor, as a faculty, by adopting some techniques, I can able to improve his characteristics. By using some methodology, learning methodology, definitely I can improve the behavior, I can improve the characteristics of the student. You got my point? So here also design engineers, what they will do is control engineers, they will try to understand the system behavior. See, once you know the system characteristics, it is easy to develop the controller. So with respect to control point of view, feedback signals should be always DC nature. To get the DC signals, we are adopting this transformation. By adopting the transformation, what you are getting? You are getting information, same information with less number of variables. You got my point? So after break, I will try to explain about the see what is the need of model predictive control. Before entering the model predictive control, first you should know what is the problem with conventional PA controller. We should know. Now before break, can I ask one question? What is the problem with PA controller? Conventional PA controller. Then after that I will give break. We can take break. Okay. You are telling so many features not there in PA controller. You have explained very good. Now my question is, what is the problem with PA controller? PID or conventional PA control. Most of the engineers, most of the industrial application, we are adopting PA only. Derivative we are not adopting. What is P? What is the function of P? P is nothing but instantaneous, right? Transient time, it is completely dependent. Dynamic responses depends on P value. I, based on the I, we can decide the steady state error. Now D, very good. Based on the D, we can decide the overshoots. Take glass of water, take bottle. Whenever you want to fill the bottle, initially it required P controller, like this, position, right? Whenever bottle is coming 80 to 90%, then you have to change the position, right? This is called integrator. Then once water is coming closely to 100%, it required derivative. Derivative nothing but you need to drops are required. That is called derivative. you need to change position. Position of the bottle is so important, right, to control the flow. Initially, this is the required position. Later, you have to change the position like this. At the end, to minimize the overshoot, to minimize the overflow, right? See, you have to change the position of the bottle complete. Now, my question is, what is the issue with controller, conventional PA controller? Function, everything already you know very well. Now, fundamental thing. After break, you can think, okay, while taking snacks, you can think. Think. See, if you understand the problem with PA controller, if there is any issue is there with existing controller, then only we have to move another controller, model predictor. If there is no problem with PA controller, we no need to adopt model predictor control, right? Clear? Whatever. See, hysteresis controller, PA controller, there is even if you take fuzzy logic controller, right? You got my point? There is a common issue is there. Think, you can discuss. This is not examination, like examination you can discuss among yourself. Come with solution after break. Then see, first after break I will try to focus on what is the problem with PA controller. After that immediately we'll shift model predictor controller. Okay, thank you. See, here before starting model predictor controller, we should know hierarchy. See, we don't have any freedom on the developing the control hierarchy, right? This hierarchy they will see, we can develop based on the actual system character. Whenever you want to develop the hierarchy, right? See, this hierarchy they have decided based on the actual system characteristics. See how many controllers are there here. You forget about what is there inside, whether it is a PA controller or model predictive based controller, right? Or hysteresis controller, or see, you forget about type of controller. If you take any type of controller, see, this is the hierarchy. The object of torque controller is it will rectify the torque error. The object of speed controller is it will rectify the speed error. The object of position controller is it will rectify the position error. You got my point? Now you got answer. What is the problem with conventional controllers, PA controllers or hysteresis controller? What is the issue with? Before break I asked, right? What is the issue with conventional controller? What is the input to the controller? What is the input to the controller? Any controller, hysteresis, or even if you take model predictor controller, what we are doing, we are calculating error. Error is the input to the controller. You got my point? What is the output of the controller? How to decide what is the output of the controller? Controller output is always cost component. Please try to understand. See, if error is the current, if there is any current error you are giving to the controller, you don't have any option. Your controller will produce the voltage. How much voltage you need to maintain across motor terminal, your controller will decide. If you maintain same voltage across the system, right, in coming samples, coming time, what happen, your current error will coming down. You got my point? See, current is the effect, voltage is the main cost component. Controller input is always effect signal. You got my point? So this effect, how we can minimize? Through cause component, through voltage. Voltage is the main cause component to control the current in electrical circuit. You got my point? Now take example, mechanical system, everyone can understand, computer science or electronics scholars also they can understand. Now in case of mechanical system, please tell me how we can eliminate the position error. How we can eliminate the position? If there is position error, how we can minimize? Through speed. You got my point? So if you take position controller, your position controller will decide how much speed we need to maintain. The position controller output is, what is the output? Speed reference. How much speed you need to maintain in actual system, your position control will decide. Speed is the main cause component to change the position. Now take speed controller, what is input to the speed controller? Speed error, right? So if you take speed error to the controller, what is the output? Speed, how we can minimize? Speed, how we can control? Through torque. So output of the speed controller is torque or current. You got my point? Understood? So if you understand this, see what I'm trying to say is, if you take any controller, many scholars or even students after completion of control system subject, they are unable to tell what is the output of the controller. Output of the controller is cause component. Input is effect. Our aim is minimizing the effect. You got my point? Control engineers aim is minimizing the effect. If error and feedback both are not matching, how we can minimize the effect? You need to send error through the controller. Once you send the current error to the controller, your controller will produce the cause component. That is the beauty of controller. Controller will decide how much magnitude or how much frequency, how much RMS value we need to maintain across the machine. It will decide. Clear? Can I ask one question, standard question? It is not related to our system. You know about RMS? You heard about RMS and average? What is the significance of RMS and average value? What is RMS? RMS, root mean square. Our systems, all systems, whatever electrical systems are there, all are responding only for RMS value. It is not responding, our systems are not responding for instantaneous value. You got my point? What is the nature of instantaneous signal to the system? It is alternating. At every instant, what is happening? Your voltage is changing its magnitude. Magnitude is fluctuating. Even though magnitude is fluctuating, glowing is not changing. It is constant, right? You got my point? All systems are responding for effective value. Practically, all are responding. It will not respond for instantaneous value. It will respond for only effective value. How much effective time you are spending on particular problem, it will decide. It will decide the output performance. You got my point? In case of electric drive also, how much torque you are producing, right? Effective torque is so important to rectify the speed error, right? So see, based on the speed, if speed error is coming down, coming instant, position error we can eliminate, right? Best example, any white paper is there so that I can explain effectively, right? Significance of hierarchy. Any white paper, A4 paper is there? A4 paper. Anyone having A4 paper? This is procedure. See, in today's session, what I'm focusing is, I'm focusing on philosophy. If you understand this philosophy behind the mechanism, it is not a big deal to adopt same technique to your system. Any white paper is there? No problem. I will return back. I will not keep with me. I will return immediately after. See, my objective is I want to roll the paper. Let us that initially this is the position of the paper. Let us assume that. See, this is the initial position of the paper. Now how many loops are there? 1, 2, 3 loops are there. You got my point? Now if you want to roll the paper effectively, you have to concentrate on inner loop or outer loop. See, using this loop, using this outer loop, we cannot roll the paper. You got my point? See, you have to take inner loop and you have to control the inner loop. What will happen if you are able to control the inner loop effectively? Automatically outer loop will follow the inner loop. You no need to put any effects on the outer loop. You got my point? This is what we are following in any control mechanism. Here, see, torque is inner loop. Torque is there in the inner loop. After that, speed controller is there. After that, position controller is there. Finally, there are 3 loops are there. These 3 controllers are connecting in cascading fashion. Right? Your job as a designer, your focus is on inner loop. You have to decide the bandwidth of the inner loop first. Once you decide the bandwidth of the inner loop, automatically other loop bandwidth we can decide simply by using thumb rule. Suppose inner loop bandwidth is 100 Hz, right? Torque loop bandwidth is 100 Hz. Next, speed bandwidth you can take 100 by 5 times less. Right? Next, position controller bandwidth you can take 100 by 5 by 5 again, or 2 you can take. So bandwidth of the inner loop should be very, very high. If inner loop is working fine, if students are working fine, burden on the teacher will coming down. If burden on the teacher is coming down, definitely burden on the HODs, burden on the deans will coming down. Right? So here your job is, you need to concentrate on inner loop. You have to decide the bandwidth of the inner loop. My question is how to decide the bandwidth. How we can decide the bandwidth of the controller. Before developing the controller, this is very important topic. You have to decide the bandwidth. See, once you know the bandwidth, it is easy to identify the KP and KA value. Clear? Our object of this program, GAN program, is predict to control. If you want to control something, what it required, you should know actual system parameter. Now my question is how to decide the bandwidth. Any controller, whether it is a PA controller or hysteresis controller or model predictor controller, how we can decide the bandwidth of the controller. Your job is you have to focus on inner loop. Inner loop bandwidth you have to decide first. After deciding the bandwidth of the inner loop, it is not a big deal to decide the bandwidth of the outer loop. Clear? Now my question is how to decide the bandwidth. How to decide the frequency of the inner loop. How to decide the speed of the inner loop. Anyone? Electrical scholars? This is very important. These points you cannot find in any textbooks. How to decide the speed of the loop based on the system characteristics. You got my point? Example I will tell. You know about solar cell, PV cell? At least you heard about PV cell, even though you are not belongs to electrical or, right? See, electronics, even computer science people also, they can see, you know about PV cell or about, you know about LED light? LED light. What is the mathematical model for LED light? How we can represent LED light? Simple resistor. Electrical equivalent circuit diagram for LED is simple resistor. Right? There is no inductance effect. Now, if take coil, take conductor, this conductor, what is the mathematical model or what is the electrical equivalent circuit for the coil? RL, R and L. Now tell me what is the difference between RL circuit and R circuit? Anyone? Okay, fine. Now current is lags, fine. Response also delay in RL circuit compared to R circuit. What is the problem with R? There is a problem is there with R. Sorry? Very good. Hmm. Hmm. See, the beauty of RL circuit is, right, it will not enter, current will not enter. Even if you apply voltage, current will accelerate. Even if you remove the voltage during certain period, current will not come zero immediately. Nothing but the ability of the RL circuit is, even if you eliminate the voltage across the terminal, current will not enter in discontinuous mode. But our problem is current will enter in discontinuous mode immediately. Reason is there is no energy storage element. You got my point? See, as a scholar, your job is, see what are the internal parameters of the system. You should know very clearly. What is the value of R, what is the value of L. You should know if inductance effect is more, you no need to go for high frequency. If student is very good, you no need to take more classes. You no need to take high frequency. You no need to operate with high frequency. But if student is below average, no option. You need to repeat the same topic more period. You have to increase the frequency. You have to operate the topic with more times. You have to teach same topic, same concept. You have to repeat 4 or 5 times. If students are very good, inductance effect is there, one single time is sufficient. They can extract this waveform. Problem with R is there is no energy storage element. Whenever you remove the voltage, immediately current is coming 0. Once your system is operating in discontinuous mode, issue is it will not obey your instructions. It will not, even if you're taking care about the control parameter in KP and KN PA controllers, or even if you're taking care about weighting factor in model predictor controller, problem will not solve. Clear? So this is the standard hierarchy. We don't have any option. You need to follow this hierarchy, even though it is a scalar control method or vector control method, right? You have to follow this structure. Then after that, later we'll adopt MPC method. Now come to model predictor control method. Under vector control method, this model predictor control will come under vector control. What is vector control? By adopting model predictor controller, we can able to control the magnitude and position instantaneously. You got my point? It is advanced control method. Now, these all the methods are coming under, there are various control technique schemes are available for power converters, right? So one is hysteresis controller, right? Linear controller, sliding mode controller, predictive controller, artificial intelligence controller. See, out of this, see this method, model predictive control become very popular compared to other methods. What is the reason? We can track the reference, we can improve the dynamic response, right? We can minimize the error. If error is minimizing, advantage is ripples are coming down. What is ripple? I will explain through MATLAB. You will get more clarity. Clear? So our focus is on, see, why we are moving to model predictor controller is so important. What is the problem with PA controller? This slide will give clarity about what is the need of model predictor controller. This is about conventional PA controller. This is about model predictor controller. Now tell me here. Observe these two diagrams clearly. You will get more clarity about why model predictor controller is needed. Why people are motivating towards model predictor controller. Example, you forget about this diagram. It is not clear. This is, I only drawn this diagram. It is not effectively. I will take simple example. Let us assume that at kth instant, what we are doing? We are calculating error. In PA controller, at particular sample, what we are doing? You need to know the information about error. This error, if you send through the controller, what you will get? Controller will give cost component. How much cost component you need to maintain in actual system, your controller will decide. That value you need to compare with high frequency triangle, that is called carrier waveform. If you compare the modulating waveform with carrier waveform, what you will get? You will get pulses. Pulses are duty period. Clear? You got my point? What is the output of the, what is the output? See, if you take sample, a particular instant, finally, after executing your logic, your logic will decide how much duty period, right? what is the duty period of the power converter will decided by the controller. You got my point? Nothing but your controller will decide the voltage, how much voltage we need to apply across the motor terminal will decided by the controller in conventional controllers. Take example PA controller. This is what we are doing. Am I correct or not? So in particular sample, we are calculating the error, we are generating the modulating waveform, we are in same sample, we are comparing the modulating waveform with carrier waveform, right? After comparing this comparison between the modulating and carrier, you will get pulse. If you apply this pulse to the power converter, your power converter will give the voltage. You got my point? This voltage we are not applying in the same instant. So your controller, your logic, whatever logic you are adopting in conventional controllers, that logic will give information about, see, how much voltage we need to apply in the next instant. You got my point? So in next instant, whatever voltage we are applying, that voltage is not completely responsible for rectify the error. In coming instant, what will happen? Error will change. Whatever voltage we are applying at k plus 1 instant, this is the instant. In this instant, we are deciding the voltage vector. What voltage we are applying in the next instant, we are deciding at kth sample. This voltage will applied across the actual system at k plus 1 instant. In k at k, at k plus 1 instant, voltage is V of k. This V of k is decided at what instant? Kth instant. You got my point? Now whatever voltage you are applying at k plus 1 instant, coming instant, that voltage is not completely responsible for rectifying the error at k plus 1 instant. You got my point? This is the problem with all conventional controllers. Where, see, whatever voltage is decided at kth instant, that voltage is applied in the, will apply in the next instant. See, in each sample, your control logic will decide the voltage value, duty period. That duty, based on the duty, what will happen? Your power electronic switches will regulate how much duty, right? It is a 40% or 80% duty, right? Will decided by the controller. If your switch is regulated with same duty, what will happen? RMS will change, average will change. These two are called effective values. By changing this effective value, we can control the variables. Now here, issue with conventional is, see, in particular sample at kth instant, we are calculating the error. We are calculating the error between reference and feedback signal. This error we are sending to the controller. Your controller is deciding voltage vector. You got my point? That voltage vector is the output of the kth instant. You got my point? That voltage is applied actually, practically that voltage, decided voltage vector will apply in the next instant. Whatever voltage is applied at particular instant, k plus 1 instant, that is not responsible for E of k plus 1. E of k plus 1 is different. Whatever voltage is applied at k plus 1 instant, that voltage is responsible for previous sample error. You got my point? What is the delay between applied voltage and error? One sample delay. If your sample time is more, you will lose accuracy. If sample time is less, you no need to worry. But nowadays our systems are so complicated, our challenges, our requirements also more. Right? Based on requirement, what will happen? Challenges are also increasing. Number of constraints also increasing. Right? Burden on the processor also increasing. Then you have to increase the sample time. If sample time is more, definitely computation burden also more. This is a very big challenging, right, with conventional machines. Because of this problem, right, this problem will motivate to adopt model predictive control. In model predictive control, what we are doing is at kth instant, we are calculating the error. What is the error, right? Error. We are, see, in conventional method, we are calculating the error. Whatever error you are calculating at kth instant, that error is E of k. But in predictive, what we are doing is, see, we are calculating the error at k, whatever error we are calculating at kth instant, that error is E of k plus 1. one sample before ahead, we are predicting the error. You got my point? You got my point? We are predicting the system behavior one sample ahead. If you know the behavior of the system, how systems are behaving in future state, if you know the information, it is not a big deal to calculate the error, right? So at kth instant, what we are doing is we are calculating the error information about k plus 1 instant. So based on the k plus 1 error, your controller will produce the voltage vector that is called v of k plus 1. Clear? At kth instant, what we are doing is we are generating voltage vector which is responsible for next instant. So in next instant, definitely applied voltage is v of k plus 1. Whatever voltage vector is applied at k plus 1, that voltage vector is 100% responsible for rectifying the error at k plus 1 instant. You got my point? This is the delay. Because of one sample delay, right? This model period to control, people are motivating towards model period to control. In conventional, all hysteresis controller, PA controller, right? If you take any controller, conventional controllers, see, compared with model period to controller, there is one sample, minimum one sample delay is there between, right, error and voltage vector. Whatever voltage vector you are applying, that is not responsible for rectifying the current state error. That voltage vector is responsible for previous state error. At current instant, error may regulate. Error will change. But in model period to controller, what we are doing is we are predicting the error based on the actual system characteristics. Once you know the characteristics of the system, we can easily develop the equations. We can, based on the equations, based on the model, we can predict. We can predict the behavior of the system. How error is changing in the next instant, we can calculate. We can easily calculate at kth instant what is the behavior of the error in the next instant. We can calculate. Once you know the behavior of the error at kth instant, it is very easy to the controller to decide the voltage vector. Whatever voltage is decided at kth instant, that voltage is responsible for k plus 1 instant. Now our problem is solved. You got my point? What is the problem with conventional controllers? Whatever voltage we are applying at particular instant, that voltage is not responsible for current state error. That is responsible for previous state error. You got my point? But in model predictive method, whatever voltage vector we are deciding, that voltage vector will take 100% responsible for current state error. Because of this reason, if you observe this response, what is the difference between, you forget about what method we adopted. What is the difference between figure, this figure and this figure? Observe carefully. Is there any difference? Is there? Ripple, thickness. You got my point? See, this is about conventional hysteresis controller with PA combination. This is completely, right, model predictive controller. By adopting model predictive controller, what is happening? Ripples are coming down. What is ripple? What is meant by ripple? Ripple is nothing but difference between instantaneous and average value. If ripple, see, ripples are less, nothing but instantaneous and average values are closely to each other. This is the ripple. This is the average. If you take ripple here, this is the bandwidth of the ripple. Center point is the average value, right? If ripples and average both are coming closely to each other, what is the advantage? Noise. In first case, noise is more. If there are any ripples are there in generated torque, this is the torque generated by the response with hysteresis controller. This is the nature of torque generated by the machine by adopting model predictive control method. Right? Now tell me, what is the advantage here? Ripples are less. Nothing but your instantaneous value is coming closely to average. If instantaneous value is coming to closely to average, noise is less. If noise is less, no oscillations in the speed response. If speed is not oscillating, passenger is more comfort in the electric vehicle application. You got my point? See, now how to develop this model. Now see, till now what we have done is we apply reverse engineering technique. Whatever technique I adopted, now till now we have not entered in the equation, we have not entered in the model predictive, but we identify what is the need of model predictor controller, we identify what is the expected output of the model predictor, we discuss, but we have not discussed what is how to implement the model predictor controller. You got my point? So now come to our system. Our system is a motor. So this is a very important concept. See, whenever you want to, why model predictor control method becomes so popular nowadays is, advantage is, whatever system you want to control, see, advantage is we have mathematical model for all existing system. If you take drives application, I have mathematical model for DC machine, we have mathematical model for AC machines, right? So we have mathematical representation of physical system. This is the advantage. Once you're having mathematical model, we can easily predict. Now, what about this side? What about this side? This is about system characteristics. Clear? Now, what about this one? This is about converters. If you take, you know about inverter circuit, what is the function of inverter? It will convert DC to AC. If you take 3-phase 2-level voltage source inverter, there are 6 switches are there. There are 3 legs are there, right? This is the power circuit. Please try to understand. This is the power circuit about the inverter, power electronic circuit, inverter circuit. How many switches are there? There are 6 switches are there. Each switch having 2 states. So 2 power 3. So how many switching states are there finally? 8. Beyond that, nothing is there in your hand. By using these 8 switching states, we can able to control the energy transfer to the system. You got my point? Energy is, this is the source. This is the motor. Right? By changing the duty period of the switch, we can able to control the energy transfer from source to machine. Based on the customer required, based on the requirement, right? By changing the duty period, we can able to control. But see, whenever you want to implement model predictor controller, see, you should know system characteristics. What is the system? Motor. Right? Next, another important thing is to control the motor characteristics, what method, what product or what device we are adopting is so important. Here what device we are adopting? We are adopting inverter model, right? See, once you know the inverter characteristics and motor characteristics, it is not a big deal to develop the model predictor controller. This is the, please try to understand, this is the standard structure for model predictor controller. If you want to develop model predictor controller, you should know actual system model, right? To change the characteristics of the model, what device is required, you should know, right? How many switching states are there in the system, in the power electron, with respect to power electronic model, how many switching states are there, you should know. What is the actual system model, you should know. By combining these two, we can easily develop the model predictor controller. You got my point? That's why. Next, one more important thing is model predictor controller, it will not work for analog circuits. It will work only for digital circuit. In analog circuit, what is the issue? What is the problem with analog circuits? Yeah. Why? What is the reason? Predictor, fixed. Your clock frequency is fixed. You got my point? See, microprocessor, microcontroller, DSP, FPGA boards, all controllers, right? Clock frequency is fixed. It will not regulate. You got my point? So, if you take analog controller, we cannot implement predictive control method. Why? Because where this one, what will happen? Sample switching frequency or execution time, all we cannot synchronize to each other. That is the issue with analog controller. But digital controller, once you know this clock frequency of the controller, right? Based on the execution time, we can decide the sample time. Sample time, you have to take fix. You have to fix the sample time, right? Then, see, for a particular sample, right? So what we are doing in model predictor controller, we are predicting the system behavior. we are predicting the torque and flux, how torque and flux are changing in the future sample, we are predicting, then we are calculating the error. 5 minutes. Fine. Yeah. See, if system is entering saturation, it is very difficult to bring back into linear zone, you know. So that's why I'm taking care about the saturation levels. I'm not bringing the system into saturation level. I'm always try to operate the system in linear zone only. Now already closely to 10 minutes to, right? I will try to wind up within 10 minutes. Okay. See here, what I'm trying to say is, whenever you want to implement model predictor controller, essential thing is you should know system behavior in terms of mathematics, right? Then after that, see what type of controller, what type of power electronic model we are adopting to change the dynamics of the actual system, you should know. Once you know the finite number of switching states, how many switching states are possible, what are the available switching states for existing converter, if you know, it is easy to implement, or it is very we can implement the combination of system characteristics and power electronic model characteristics. These two will give the right will work. See, if you know these two effectively, we can implement predictive control. Clear? Understood? So based on the switching characteristics, we can control the variables. But here, see, what is the problem with conventional controller? We discuss, right? Whatever voltage vector is decided at particular sample, that is not responsible for rectify the error at current state. That voltage vector is responsible for previous sample. You got my point? So that's why by using this mathematical model, by using the mathematical model of the actual system, we can predict the error. What is the nature of error in the next sample we are predicting, right? So based on the switching state, based on the finite number of switching state, we can identify the optimal voltage vector. You got my point? What we are doing in model predictor, we are iterating the cost function. What are the, see, many scholars, they are unable to identify the how to design the cost function. Whenever you want to design the cost function for a particular system, you should know target parameter. What are the target parameters for electrical drive? Our system is an electric drive. What are the target parameters? What are the target parameters? Torque and flux. These two things should be there in cost function. You got my point? These two you have to bring into cost function based on our system. Our system is a drive, motor. Whenever you want to control the motor speed or position, you need to control the torque. While controlling the torque, see, important thing is you need to minimize the number of variables in the torque profile. If you want to minimize the number of variables in the torque profile, you don't have any option. You need to maintain magnetizing flux constant. If magnetizing flux is constant, advantage is number of variables involved in the torque expression will coming down. We can convert it from nonlinear to linear. That's why these two variables you have to focus. No option. Same thing, same concept you can adopt to your system also. Whenever you want to adopt model predictor controller to your system, your job is you need to identify target variables. Right? What is the expected output of your system? You need to identify first. Right? To control that variable, what parameters we need to maintain constant, you should know clearly. Once you know the characteristics of the system, we can easily decide the cost function. This is the mathematical model for cost function in predictive controller for electrical drive system. Even if it is a induction motor, or even if it is a synchronous machine, or even if it is a BLDC motor, or even if it is a switch reluctance motor, cost function will not change. This is the fixed. Why it is fixed? In all motors, target variables are torque and flux. But if you want predict, here this is the reference torque. From where this signal will come? Reference torque, from where it will come? We discuss hierarchy, right? Reference torque is coming from speed controller. You got my point? Reference torque will decided by the speed controller. Second loop will decide the reference torque. You got my point? So here what we are doing, we are trying to focus on inner loop. If you focus on inner loop, automatically outer two loops will follow the inner loop. That is the strength of inner loop controller. That is what we discuss through this example, right? If you focus on inner loop, what is the advantage? Your outer loop will follow automatically inner loop. Clear? So that is, we are focusing on inner loop. If you focus on inner loop, we are trying to minimize the inner loop error. Automatically, outer loop will follow the inner loop. Clear? Anyone having doubt up to here? This is the cost function. This cost function, you have to iterate how many times? In a sample time, how many times you have to iterate this cost function? This cost function you have to iterate, right? How many times? How to decide the iteration, number of iterations? It is based on control circuit. It is based on power circuit. How many switches are there? See, here if you take this circuit, how many switching states are there? 8. Beyond that, nothing is there. With 8 voltage vectors, we need to iterate the cost function, right? If you iterate the equation 8 times for different switching states, right? What will happen? Cost function value will regulate. At what switching state your cost function is coming down, that is called optimal cost function, right? So at the end of sample time, right, your cost function will decide the optimal voltage vector. That voltage vector is responsible for eliminating the error in future sample, coming sample. Why? Because here what we are doing, we are not calculating the error at kth instant. Please check here. See, what is the value of error here? K plus 1 error. We are calculating torque error at K plus 1 instant. Flux error at K plus 1 instant we are calculating. We are calculating next sample error. You got my point? So this is the advantage of model predictor control method compared to conventional methods. Even if you take HTCs or PA controller or fuzzy logic, any method, there is a issue is there, one sample delay is there in error control. Error we are not control exactly at particular sample. Whatever error we are controlling on particular sample, whatever voltage we are applying at particular sample, that voltage is responsible for previous error. But by adopting model predictor control method, we can take care 100% responsibility to eliminate the error at same sample, right? Clear? So here, so based on power circuit, we can decide how many number of times we need to iterate the cost function. We can decide. Here 8 switching states are there with respect to power converters. You have to iterate with 8 times. So after iterating with available voltage vector, you will get different cost function. You will get different errors. Magnitude will change. So if you take this one, V2 will give optimal value of the cost function, where V2 is called optimal voltage vector. This voltage vector is responsible to eliminate the error in coming sample. You got my point? So this is how model predictor controller is working. If anyone having doubts, you can ask. Now because of time constraint, I need to stop here. I don't know how many participants are following or not. I don't know really. At least even if you understand delta X also, it is fine. Changing the system response delta X is also very important with input. You got my point? Clear? Anyone having doubt? So same, this is the response. This is the response simulation results, right? About the different methods. First one is PA controller with hysteresis base. Second one is model predictor control. You can see steady state error is very less. But conventional method, if you take, ripples are more. Clear? Shall I stop here? Okay, thank you. Sorry? Later, no. Later, I don't have any session. Okay. If you have any doubts, you can post. You can request your coordinator. I will address. Okay. If you are having any query in future, you can write on paper, white paper. You can submit to coordinators. They will forward to me. I will respond through mail, or I will respond through any other technique. Okay. Thank you. I'm telling, see, whenever you want to do something, first important thing is whenever you want to control system, right? Any method, first important thing is you should know actual system behavior. Through mathematics, you have to understand. If you are very strong in mathematics, almost 90% problem will solve. Okay. Thank you.